So hello everybody. Hi. Good evening, good afternoon, Andariki. Hi. Good afternoon. Abba. Abba. Okay. Okay. How is everybody? How is your energy levels? Chepandi, you have been attending the classes from morning itself. Da? Good evening. It should be good afternoon, right? Good evening starts from 5 p.m. Yes. So, start the chapter, finish the chapter. Okay? One shot. Aim chapter, sir. Center of mass. Okay. How are you all? Okay, sorry. Cheppandi. Not sure teaching. Ade kada. So, ఈరోజు we will start with center of mass. And ఇదే we will end it also. అదే కదా? Right. Good afternoon. అందరికి. Yes. I'm also fine. Good afternoon, Andariki. Good afternoon. Okay. Great. Sure. So, do we have some experiments to do there? Do we have something? No, we don't have any. Okay. Cheppandi Andariki. Some settings are missing. Just a minute. Huh? Good evening, Shalini. Good evening. Okay. So now, whoever is in the class, my sincere recommendation will be to attend this class from the beginning till the end. Ade kada? Just a minute. Okay. Good evening. Okay. So, the introduction ante, what are the prerequisites required to discuss this chapter? Good news. No prerequisites. Yes, there is a certain prerequisites that you must be good with the vectors ra. Ide. Because sari vectors hochi, then you don't need anything to understand this chapter. Right? Yes. Great. So, yes, here it is. Center of mass ante enti, sir? I will tell you some experiments, okay? You try to do these experiments by yourself, okay? You can go to a wall. I don't know if there is, you can see the wall or not, but here is this wall, right? Okay, here. Can you see? Can you hear the mouse? This is the wall right here. Okay? You can't see me. Okay, let's do one thing. You just stick yourself to the wall. Okay, I'm sticking myself to the wall. Chuskondi. This is the wall. Now, this is the portion of me that is actually attached to the wall, right? Yes, this side. And this side is absolutely free. This side, this side, this side. So I want you to lift your head, leg. I want you to lift your leg something like this. Lean against a wall and try to lift your leg something like this. You will not be able to do that. Are you understanding? Good evening, Maitri. Very good evening. Very good evening. Very good evening. You won't be able to do that. Why, Re? Enduku, sir? Because wherever you move, before you, your center of mass should move there. Ante enti, sir? What are you talking, sir? You're not understanding anything. Chuskondi. Center of mass ante, it is a imaginary point, ra. Listen to me very carefully. Center of mass ante, it is the imaginary point at which the entire mass of the object is concentrated. Ante enti, sir? I don't understand. So let us imagine this is the book, right? So particles are there everywhere on this book. Everywhere. Yes. Particles are there everywhere. But a book pai oka point untundira. A point pai the total mass of the book is concentrated. So if I am able to find that point, my total book will be balanced. This is class 8th science textbook. So let us try to find that book, point. Hey, this is the point. Can you visualize? This is the point. And if I only want to hold the book at a given point, you can hold it at the center of mass of that point. Right? Are you able to understand? Symmetric figures unte, the center of mass lies exactly at the center. Sir, how did I come to know? Choose kora. Symmetric figure kada? Yes, sir. This length, same. This length, same. Ante this yellow dot that you're seeing, it is exactly at the center of the book. So I don't have to do anything, Ray. I've ready-madely got this center of mass point. So what I'm doing now is, I'm just placing my finger at this point, and that's it. The book is balanced. Book is balanced. Yes. Chusko. So the point at which I am placing my finger is the center of mass of this book. Same goes with each and every figure, Ray. Same goes with each and every figure. Choose one. Yes. Okay. Yes. So I want to find the center of mass of these two. Cheppandi. Sir. Hey, you listen. Okay, you listen. These are symmetric figures. Okay, these are symmetric figures. And the center of mass of this figure will be at the center. Yes, somewhere here. Kani. This extra part is there, right? So this will have its own center of mass. Where is it? Sir, exactly at the middle. Now you ignore this thing. Now only focus on this. This. Ide. You focus on this. Cheppandi. The center of mass of this lies somewhere here. Right. So, sir, first figure ki center of mass is lying at the center. The second figure center of mass is lying at this center, sir. So the center of mass of total system should be somewhere in between them. Somewhere in between them. Right. So I believe the center of mass should be here. Choose Kondi. Are you able to understand? It should be in the frame. This is the center of mass. Balanced kada? Yes. So that means the entire mass of this shape, it is concentrated at a given point. Okate point untundira. Mottam figure lo ade kada. Now the center of mass of the objects could be at the center, could be on the object, leda it could be out of the shape also, out of the figure also. Ade kada. Right. Great. Center of mass ante enti, sir? Center of mass. Cheppandi endariki. So center of mass is an imaginary point. At which Not imaginary ra, is the point. It could be imaginary also, it could be real also. Ade kada, center of mass is a point at which the entire mass of the object is concentrated. Entire mass of the object is concentrated. Just got it. Okay, that point, yes, good, very good, go not very good. So that point may be on the object, it may not be on the object, it may be out of the object also, on the object also, inside the object also. Ade kada. Hey, are you listening to me? Right. Cheppandi. So sir, how to find that point? Ade kada. Before telling you that, andariki, I am going to tell you the biggest secret. Okay, biggest secret. What is the secret, sir? Point number one. You understand. Okay, you understand this. Point number one. ఒకసారి మీ దగ్గర సెంటర్ ఆఫ్ మాస్ కి పాయింట్ ఉంటే you do one thing, you replace the total mass at a given point. I'll tell you, చూసుకోండి అందరికి. So if I'm talking about this random figure, total mass m is there. M అంటే let us say 1000 kgs. 1000 kgs రా, చాలా పెద్ద మాస్ కదా. Yes. So you find the center of mass and I'm telling you that the center of mass, let us say, is somewhere here. Andarki chuskondi, the center of mass is somewhere here. Hey, are you understanding what I'm telling? If the figure is bounded or limited, the center of mass is inside the figure. Don't worry, I'll tell you. Chuskora. If the body of mass is given, point number one, find the center of mass. Ade. So this is the center of mass, sir. Ippudu em cheyali? The second immediate step that you will do is you remove all the body and you only take that center of mass ra. Chuskondi. Ee mottam body ni remove chesi ఒకటే పాయింట్ అంటే సెంటర్ ఆఫ్ మాస్ తీసుకోండి. దిస్ ఈజ్ మై స్మాల్ పాయింట్ కదా. ఎస్. నౌ at this small point is your total mass. అంటే ఈ స్మాల్ పాయింట్ కి మాస్ ఇప్పుడు ఐ విల్ టెల్ యూ ద టోటల్ మాస్ ఆఫ్ దిస్ పాయింట్ బికమ్స్ 1000 kg. అదే అంటే ఏంటి సార్, ద టోటల్ మాస్, ఈ బాడీలో ఉన్నది టోటల్ మాస్, ఇట్ ఈస్ కాన్సన్ట్రేటెడ్ అట్ ద సెంటర్ ఆఫ్ మాస్. సో వెన్ యూఆర్ టాకింగ్ అబౌట్ ద పార్టికల్స్ చూసుకో, ఈ ఫిగర్ లో అంటే ఈ షేప్ లో దేర్ ఆర్ n number of particles, right? N number of atoms are there, millions, billions, trillions of atoms are there. Ade kada, right? So which all will you keep taking, right? Are you understanding? There are billions of atoms into it. Kani we can't talk about each and every one. Ade kada. So that is the reason why there will be some condition. Hey, listen to me. In the future, there will be a condition at which you will have to take these bodies and do some work ra. Chuskondi. In future, you will have some conditions in which you will have to take the entire body and do the calculations. Danikante it's a very big headache ra. Infinite part, not infinite. Millions and billions of atoms are there. I can't deal with it. So the simplest way is you take the entire mass and focus it only on the center of mass. So ekkada you have billions of particles kada, you have billions of particles, they have been converted into one single particle having the mass of 1000 kg. Ante your efforts have been saved by a huge factor. Remember this, always remember. Why do we find the center of mass? Only because we have to convert the entire mass at a given point. Ade kada, a point parent is center of mass. Understanding, not understanding, andariki cheppandi. number 1 తీసుకోండి. Step number 1. What is the step number 1, right? Find the center of mass. అదే కదా. Next step. After finding center of mass, replace the entire object, the entire body, replace the entire body with a single point ra. Ade kada. Replace the entire body with a single point, but its mass, whose mass re? Point's mass. Ade kada. Point's mass should be equal to, చెప్పండి అందరికి, should be equal to entire mass of the body. Understanding? Okay, good. Okay, next. So, ఈ center of mass find చేయడానికి the scientists they have given us some formulas ra. Scientists they have given us some formulas. The first thing, మొదటిగా they told us that whenever you find the center of mass, listen to me very carefully students, whenever you are going to find the center of mass, calculate the x center of mass or the center of mass of x coordinate in x axis only, y coordinate in y axis only. చూద్దాం అందరికి, చూసుకోండి. So if I have a point ra, point చూసుకోండి, this is a small particle అదే కదా, this is a small particle, mass, let us say mass m is equals to 10 kg ra. What is the center of mass of this particle, sir? This is only the center of mass, it's a point kada. Yes, so this is only the center of mass having total mass is equals to 10 kg. ఇప్పుడు if I make the change to this system, అందరికి చూడండి, 10 kg mass is there ra. If I introduce one more mass to it, చూసుకోండి అందరికి, if I introduce one more mass to it, so let us say I am introducing that mass here, and let us say that mass is 20 kg అందరికి, and let us say the distance between these two is 10 meters అదే. Okay, if there was one mass, ఒకటే mass ఉంటే ఆ mass point will be the center of mass. కానీ if I am introducing one more point, the center of mass of the total system is changing. Understanding? The center of mass of the total system is changing. అంటే సార్, what will be the new center of mass? దీనికోసం చూసుకోండి అందరికి, దీనికోసం step number 1, I'm telling you, okay, to find the center of mass, అందరికి చూడండి, to find the center of mass, step number 1, take an origin ra. Okay, choose a suitable origin. Sir, where should I take the origin in this system ra? Where should I take? I can take at the mass also, లేదా I can take at this mass also, లేదా I can take at the middle point also, లేదా I can take at a general point. I can take anywhere, right? Your answer will not change. The choice of origin will not change your answer ra. అదే కదా, you must choose an origin. ఎక్కడ సార్? You can take wherever you want. But smart logic says that you choose the origin such that your calculation is simplified. Calculation is simplified అంటే ఏంటి రా? Calculation is simplified అంటే ఏంటి? Hey, what is going on, right? Okay. So when you talk about, right here, just one. So the first step is to choose the origin. You can take it wherever you want, but now I am taking that origin at one of the given points. చూసుకోండి అందరికి, origin అంటే ఇదే. ఇప్పుడు origin తీసినప్పుడు you imagine the distances of both the masses from the origin. అంటే the distance is step number 2. It is my step number 2. Andariki. Observe it very carefully, okay? Step 2 is calculate distance of each mass from origin. These are the 2 things that you have to do, Ray. If you are done with these 2 things, if you are done with these 2 things, okay, if you are done with these 2 things, the only formula to find the center of mass is this. Chuskondi. R center of mass, it's a vector form, re andariki. Formula group pettukondi. Formula is very important, okay? Formula is very important. Hey, listen. You have your NEET examination in your 3 months, and you are doing all this nonsense in chat box. Sometimes it's okay, but all the times doing this nonsense in the chat box is not, what should I say? You must be careful, okay? Whatever you are getting here, if you are wasting your time in doing all these things, everything is gone, okay? Okay, let us see. So, interested students, jagrataga vinandi, okay? Next, R bar center of mass is equals to M1 R1 bar. My health is not good today, Still I am coming and teaching. So, you should have some respect for the subject at least, okay? Plus M2 R2 plus M3 R3, ade kada? And so on and so forth. And Mn Rn bar divided by M1 plus M2 plus M3 and so on up to Mn. Ide kada? Right. So this is the formula for the center of mass. Calculate cheddam andariki. Let us try to calculate the center of mass for this. And then we will see for different systems. Chuskondi. This is my first mass, 5 kg. This is my second mass. It is equals to 10 kgs andariki. And the distance between the 2 is 10 meters. Cheppandi, how will I write the center of mass of the 2 system? In this class, we are only studying the center of mass of 2 systems. Cheppu. Sir, I am choosing the origin right here. So this is my origin. Ade kada? Right. So ide origin unte, sir, the distance from origin of the first mass is 0. Ante R1 bar is equals to 0. Ade kada? Same point, same origin, distance is equals to 0, right? Good. Now, calculate the second distance, R2 bar, value enti 10 meters, ade kada? Right. So, what will you write the formula for the center of mass? R bar center of mass is equals to M1 R1 bar plus M2 R2 bar divided by M1 plus M2. Ante enti ante M1 value pettandi 5 kg into R1 bar is 0 kada? Yes. Plus M2 value enti 10 multiplied by R2 value cheppandi 10 ide divided by M1 plus M2 ante total mass ki addition 5 plus 10 ade kada? Right. So it is equals to 100 by 15 ante 20 by 3 meters. 20 by 3 is approximately equals to 6.666 kada? Yes. So it is approximately equals to 6.66 meters. Chuskondi. From what? Idi na calculation ochindira, naku answer kuda ochindi. But where is the position? Okay? Where is the position? Cheppandi. Where is the position? Okay? Where is the position of the center of mass? Sir, 6.666 meters from origin, right? So, idena origin, and from this origin, the center of mass is at a distance of 6.666 meters ante this. Now, my question to you is, chuskondi andariki. Mass is 5 kg, ekkadochi mass is 10 kg, ade kada? So, the center of mass is closer to which object? 5 kg, 10 kg, 10 kg, right? Ante, if you have heavier objects, the center of mass will be shifted towards them. In case lo chudandi, there is simply the space between them, right? No line, no rod, no string, nothing at all. Ante, the center of mass is an imaginary point, Ray. It is not, it cannot be seen, it cannot be touched. Good, very good. It cannot be done anything. Ade kada? Right. So that means the center of mass is an imaginary point. Ade kada? Right. Next, I'll give you one more question. Andariki, cheppandi. So in this scenario, I'll be taking 3 masses. Okay, now I want the answer. 5 kgs. This is 10 kgs. Okay, and this is 15 kgs. I'm giving you the distances also, ra. Cheppu. So this distance is 6 meters, and ekkadochi the distance is 8 meters. Andariki cheppandi. Now, again the 2 steps that you have to do. Again the 2 steps. What 2 steps, sir? Step number 1, choose appropriate origin. Step number 2, every mass distance you calculate. Dan tarvata formula tisi, formula lo values petti answer calculate cheyandi. Okay? Okay? Ugh. 6 meters. So where is the origin, Janvi? The answer 6 meters is not a complete answer. Okay. So answer when you are telling the answer, you must say 6 meter from which mass and in which direction. Okay. It's a vector, ra. Okay. It's a vector. It's a vector. So vector unte, you must be having both the things. Ante you must be knowing the value also and direction also. Ade kada? Right. 6 meter from what? Okay, first of all, tell me, what are you taking as the origin? What is the origin? What is the origin, Ra? So, in case, no, you can take wherever you want as origin, okay? You can take wherever you want from origin. So now, I'll show you in all 3 ways, okay? I will take the origin at this point first. Then I'll take the origin at this point, and then I'll take the origin at this point. Ade kada? Chuddam, andariki, cheppandi. So when I'm taking the origin at this point, andariki cheppandi. So ide na origin kada? So ee origin unte, values cheppandi ra. Masses, masses 5 kg. It is 5 kg, okay? It is 5 kg. Cheppandi. Sir, M1 is equals to 5 kg. M2 is equals to 10 kg. 15 kg. Ade kada? Right. I'm doing it very quickly. Andariki chudandi. R1 is equals to 0. R2 is equals to 6. 6. From the origin, 6. R3 value, ra. R3 value is equals to 14 meters. Ante kada? See, this 6 and that 8. Complete distance of the mass from origin. 14 meters. Ade? Right. Values cheppandi ra. Now tell me the formula and substitute the values, ra. So R bar of center of mass is equals to M1 R1 bar plus M2 R2 bar plus M3 R3 bar divided by M1 plus M2 plus M3. Ade kada? M1 value substitute 5 into R1 bar 0 plus M2 value enti ra 10 into R2 bar. What is the R2 bar? 6 plus M3 value cheppandi 15 multiplied by R3 bar is 14. Divided by M1 plus M2 plus M3 kada. So 5 plus 10 plus 50. So that is equals to cheppandi andariki. So it is 60 ra. 60 plus 210. 210. Yes. 210, right? 210. Yes, 210 divided by 30. Right. Perfect. So 60 plus 210 is 270. 270 by 9 is 30 and 270 by 30. It is equals to 9 meters. From what mass, Ray? From my origin. From my origin. From my origin. Where is the origin, sir? Where is the origin? Where is the origin? Chuskondi. Origin is here, Ray. This origin is 9 meter ki distance lo. So that means from here it is at the total 9 meter distance. And this is 6 meters and remaining is 3 meters. Chuskondi. So this is 6 meters and remaining is 3 meters. again మళ్ళీ ఈసారి కూడా the center of mass is towards the heavier mass అంటే 15 kg అదే కదా, right? So your answer should be 9 meters from the origin. So a question I have taken, you understand the position of the center of mass first. Hey, the center of mass is between 10 kg and 15 kg block అదే కదా. పొజిషన్ చూసుకోండి అందరికి. పొజిషన్ it is in between 10 and 15 kg block. ఎంత డిస్టెన్స్ రా? At the distance of 3 meters from 10 kg. అంటే this is the distance of center of mass and this is the position of the center of mass, right? Good. Now I'll take the same question and I'll change my origin. Okay, చూద్దాం అందరికి. Origin change చేసి what will be the answer రా? ఇదేనా 5 kg block? This was my 3rd kg and this is 15 kg block అదే కదా. Distances చెప్పండి అందరికి. 6 meters and this distance was 8 meters అదే కదా, right? Now I'm telling you very conceptual clarity. Okay, everybody of you you understand the concepts అంటే ఏంటిరా? ఇప్పుడు I'm imagining my origin at this point రే. Okay, what is the formula, sir? Formula is r bar of center of mass is equals to m1 r1 bar అంటే direction కూడా matters. Okay, direction also you have to consider plus m2 r2 bar plus m3 r3 bar divided by total mass is m1 plus m2 plus m3 అంతే కదా, right? What is the value of r1 r2 r3 bar చూసుకోండి. ఇదే నా మాస్ m1 అంటే 5 kgs అంతే కదా. This is my mass m2 is equals to 10 kgs and ఎక్కడ వచ్చింది మాస్ m3 is equals to 15 kgs అదే కదా, right? అందరికి చెప్పండి. Now when I'm talking about r1 ఇదే నా origin రే అందరికి. This is my origin అంతే కదా, this is my origin. ఈ origin నుంచి m1 కి డిస్టెన్స్ ఎంత రా? So this is the origin, this is the mass m1, ఈ distance అంటే 6 meters అదే కదా. Should I write r1 is equals to 6? So ఇక్కడ నుంచి I'm writing r1 bar is equals to 6 meters. r2 bar ఎంత రా? Sir, r2 bar is the distance from origin to the second mass. Both are same అంటే r2 value is 0 అదే. ఇప్పుడు r3 value చెప్పండి రా. r3 value is equals to distance of third mass from the origin is 8 meters అదే. My assumptions are right, correct? Okay, you can choose any origin you want. Are my assumptions correct? No, I did a mistake. Okay, mistake చేశాను. What is the mistake చెప్పండి అందరికి. I did a mistake, for sure I did a mistake. Okay, my assumptions are not good, right? Somewhere it is mistake. Where is the mistake? చెప్పండి అందరికి. Can any one of you tell me? There is a mistake that I committed. Previous case lo there is no mistake. Everything is going very smooth and fine ra. Kani ee case lo I am committing a mistake. What is the mistake? Cheppandi andariki. My answer will not be coming good. The mistake is if this is my origin, that is 8. Direction right. Value 8 plus 8. This is in the left side. Direction left. Value 6. Sign -6. It should be -6. Ade bar kada. Bar ante direction also matters re. Good. Very good. SVM technology channel. Very good. So the value of R1 is -6 and R2 is 0 and R3 is 8. అంతే కదా, గుడ్. చెప్పండి ఇప్పుడు వాల్యూ చెప్పండి. సార్ r bar of center of mass it is equals to m1 r1 bar plus m2 r2 bar plus m3 r3 bar divided by m1 plus m2 plus m3 అదే కదా, రైట్. ఇప్పుడు వాల్యూ సబ్స్టిట్యూట్ చేసుకోండి. m1 వాల్యూ అంటే 5, r1 bar ఎంతనా? r1 bar is -6 meters. And remember, I'm telling you, your answer అంటే ఏంటిరా? ఫైనల్ వాల్యూ ఎంత వచ్చింది ఇక్కడ? 9 meters కదా. You will not get the same final value. చూసుకోండి, your answers will be different but the position will be same. Position ఎక్కడ ఉందిరా? Position is between 10 and 15 kg block and the distance is 3 meters from 10 kg. Ade kada. Here also you will get the same position, but the value will be different. Endukante you are changing the origin, right? Yes. So substitute m1 ante 5 multiplied by r1 bar. R1 bar entara -6 plus m2 bar is how much, sir? M2 bar is 10 multiplied by r2 bar is 0 plus m3 bar value cheppandi. M3 bar is 15. R3 bar it is in the positive side kada. It should be 8 divided by total mass ki addition 5 plus 10 plus 15 ante directly rastunnaru 30 kg ade kada, right? Cheppandi. So it is -30 plus 0 plus 120 yes, plus 120 divided by 30 kada. Yes. So 120 divided minus 30, how much? 120 minus 30 is 90. 90 divided by 30, it is equals to 3 meters. Choose code. The final answer is different. If you are changing the origin, final answer kuda march. It will change. See, here it is 9 meters, and here it is 3 meters. But the position. Okay? Position. Yes, with the directions also. You have to take the distances with the directions. Position. You imagine the distance r bar. Your answer is positive, negative. Your answer is positive. Kada. Positive ante em direction? Right side. Right side is the direction and value anta 3 meters. So ikkada nunchi 3 meters is your center of mass. Chuskondi. Again the same thing. Same thing as that this. Ikkada kuda 3 meters from 10 kg. Here also 3 meters from 10 kg. Ade kada. Now I want you to do it by yourself. Okay? Okay? Next. You take this very question, right? You take this same question only. Same question, but. Take the same question. This is my 5 kg block. Ide na 10 kg block ra. Okay? And this is my 15 kg block. Andariki cheppandi. This is my 15 kg block. But this time, I want you to imagine the origin at that point. Okay? I want you to imagine at that point. Origin. Janvi, origin choosing is not mandatory. It should not be found, right? It should be chosen. So completely on your choice. It's completely me ishtam. You can choose wherever you want. E distance ante 6 meters kada. Yes. And here the distance is 8 meters. Andariki. Now I want you to take the origin at this point. At this point. Andariki. I want you to take the origin at this point and tell me the center of mass. R1 bar, R2 bar, R3 bar. Ade. R1 bar, R2 bar, R3 bar ki values, they only keep the significance. Okasari meeku values pette, everything becomes simplified. Cheppandi andariki. So if I am taking the origin at this point, you listen all of you, okay? I will do it. So if at all I am taking my origin at this point, this is my third mass kada. M1 value cheppu. M1 is equals to 5 kg. M2 value enta? M2 is equals to 10 kg. Okay. M3 value how much, sir? M3 value is equals to 15 kg. Ade kada. If you are not understanding, students, keep asking me, okay? If you are not understanding, keep asking. I'll repeat it 3, 4, 5 times, okay? Don't worry, but keep doing. Now, origin at that point. Naku R1 kavalira. R1 is right there. Chuskondi. Very far point. This is my R1. This is my origin. Distance. How much distance? Total distance. Total distance is 6 plus 8 ante 14 meters. Direction. Left side. So direction left lo unte very good. Go not very good. So R1 ki value ante minus 14 meters. And what about R2 re? R2 value is equals to, idi kuda left lo kada. Yes, so this also becomes minus 8 meters. What about R3? R3 is at the origin itself. So that means R3 ki value, it comes out to be 0 ra. Ade. Ippudu directly take the formula. What formula, sir? R bar of center of mass is equals to M1 R1 bar plus M2 R2 bar plus M3 R3 bar. Rendu masses kada. So 3 terms divided by M1 plus M2 plus M3. Cheppandi andariki. M1 value is 5. R1 value is minus 14 plus m2 value ఏంటిరా 10 multiplied by r2 value ఎంత -8 plus m3 value చెప్పండి అందరికి 15 r3 is 0 divided by m1 plus m2 plus m3 అంటే ఇక్కడ కూడా 30 అదే కదా yes so -70 -80 divided by 30 అంటే -150 by 30 negative answer is coming okay answer is coming as negative answer is coming ray good very good very good so that means my -5 meters is the center of mass r bar of center of mass చూసుకోండి if the center of mass is negative ante your direction is towards the left if the center of mass is positive ante your direction is towards the right so this is my origin and ఈ origin నుంచి -5 meters అంటే left side లో వెళ్ళండి you go -5 meters in the left side అంటే this is -5 so అంటే this distance should be -5 అదే కదా left side this is my center of mass చూసుకోండి if it is -5 total distance is 8 ray this is 5 total 8 this is 5 total 8 this is 5 this automatically becomes 3 right yes చూసుకోండి అదే here also you are getting the same position does not change okay position does not change yes minus good parimala both are minus okay good no it should be -5 wahalasya it should not be 5 it should be -5 ante left side lo ade kada right so now let us talk about a shortcut formula okay మొత్తం సారి we are not going to use the same formula again and again ra చూసుకోండి okay I will just quickly go through a formula చెప్పండి అందరికి this is my mass m1 చెప్పండి this is my mass m2 అంటే ఈ సిస్టమ్ లో రెండు masses ఉన్నాయిరా సో ఒక 2 mass system ఉంటే you must remember the formula for center of mass okay you must remember okay చెప్పండి సో ఈ రెండు masses లో distance is d okay d distance ఉంటే I directly must remember the formula for the center of mass ఏంటి సార్ ఫార్ములా చెప్పండి అదే సేమ్ థింగ్ assume the origin at any one point you can take wherever you want okay good very good Gitanjali very good so I am assuming the origin to be at this point so ఇదే నా origin రా point O అంతే కదా right so sir origin is here and the second mass is here అదే చెప్పండి అందరికి so these are my two masses m1 value is m1 only r1 చెప్పండి రా r1 value ఎంత సార్ r1 is equals to 0 bar కూడా తీసుకోండి ఎందుకంటే డైరెక్షన్ ఆల్సో మ్యాటర్స్ కదా yes m2 value is m2 r2 value చెప్పండి r2 bar is r2 only అదే కదా it is r2 only it's in the right side so you take plus so now you do one thing you apply the formula r bar center of mass it is equals to చెప్పండి అందరికి r bar of center of mass is equals to m1 r1 bar plus m2 r2 bar రెండు masses కదా divided by m1 plus m2 అంటే ఏంటిరా r1 bar is 0 అంటే ఎక్కడ the value is coming 0 అంటే this is gone yes sir the remaining value is m2 into r2 value ఏంటిరా r2 is not r2 I'm sorry r2 is not r2 is the distance of the second mass from the origin అంటే total distance d రే r2 is d okay r2 is equals to d చెప్పండి అందరికి so m1 r1 gone plus m2 into r2 is d ray divided by m1 plus m2 అదే కదా so ఇదే నా సెంటర్ ఆఫ్ మాస్ ఫార్ములా గుర్తుపెట్టుకోండి m2d by m1 plus m2 you have similar formula in acceleration of atwood machine also గుర్తుందా are you understanding acceleration of atwood machine sir m1 minus m2 by m1 plus m2 into g similar expressions చూసుకోండి this is something okay yes so this is the formula for the center of mass లేదా you want to change the origin you can change the origin also ra again I'm shifting everything this side and let us change the origin and see the expressions okay so this is my first case again even in the second case andarki chudandi okay I want you to imagine or focus on the formulas first of all formula lo focus cheyandi andariki okay yes for two masses only for two masses you understand okay you understand It's a very golden statement, all of you. Okay, yes. Only for 2 masses, this is the formula only. Because in your examination, you will not be given 3 masses. It mostly asks about 2 masses only. So all the times writing the formula, you just remember this formula, okay? Leda, I'm changing the system, ra. Chuskondi. This is my first mass, M1. Ide na first mass, M1 kada. This is my second mass, M2 andariki cheppandi. And the second distance between them is D andariki. All of you. Now I'm assuming the origin at that point. Ante when you are seeing everything from this mass point of reference, you are getting this formula. But if I see the system from that mass point of view, ante reference point, and I am assuming origin at that point, cheppandi, what will be the results? So this is my origin andariki. Ide na origin. Ade kada. Cheppandi. M1, R1, M2, R2 values. What are the values of M1, R1? Hi Isha, hi Isha, hi. M1 is equals to M1. R1 value entira. M1 is M1 only. What is R1 value? Right, Gitanjali, very good. What is R1 value? What is R1 value? What is R1 value andariki? Cheppandi. M1 is M2. No. Signs will not change, but you'll see. Okay, signs will also change. It will also change. Sign here it is positive. It's not negative. It's positive. But here the answer will be negative. Ekkada the answer will be negative, right? Cheppandi. Sir, M1 is M1 only. M1 is M1. Ade kada? Yes. R1 value cheppandi ra. R1 value enta. R1 ante distance of M1 from origin. Not D. Again, you are doing the same mistakes. It's not D. Direction also matters. Direction also matters. Okay. Direction also matters. It is not D. There is the origin ray, and we are coming in this direction. Until left side. It is minus D. Okay. R1 is good. Very good. R1 is minus D andariki chudandi. In the direction, if you are forgetting it, until your answer will also be gone. Okay. Sign until negative until left side, positive until right side. The same process. If you are assuming upwards, it should be positive y, downwards it should be negative y. Ade kada? Right. So this is my minus D value ray. Cheppandi, ida ekkada M2 is equals to M2. Ade kada? What about R2, sir? R2 is equals to 0. ఇప్పుడు ఫార్ములా సబ్స్టిట్యూట్ చేసుకోండి. R bar of center of mass, it is equals to M1 R1 bar plus M2 R2 bar divided by M1 plus M2. అంతే కదా? Yes. M1 value ఏంటిరా? M1. R1 bar అంటే minus D plus M2 into R2 is 0 రే divided by M1 plus M2. అదే కదా? M1 plus M2. It is gone. What is remaining? R bar of center of mass is equals to M1 negative sign. Okay, sign kuda teeskondi. Hey, don't forget the signs. Andariki. It is negative D. Chuskondi. So it becomes minus M1 into D divided by M1 plus M2. So this is my center of mass with respect to the second mass. Ante in the left side. Ade kada? Now, not equal. They are not equal. Chuskondi. Here M2D by M1 plus M2. Here M1D by M1 plus M2. So if you are taking center of mass from M2 side, it will be M1D by M1 plus M2. And if you are taking this from M1 side, it will become M2D by M1 plus M2. Ante kada? Yes. So they are blaming each other. Okay. So if M1 is there, he is telling my center of mass is dependent on M2. Chuskondi. M1 is there. Kada? Origin ante M1. M1 is there. He is telling that my center of mass is dependent on M2 ra. M2 unte he is telling my center of mass is dependent on M1. Ade. Are you understanding? Right. So let us take a question. Direct ga oka question teeskunnaru. Chuskondi andariki. So this mass is 10 kgs. Okay. This mass is equals to 30 kgs ra. 30 kgs. Cheppandi andariki. If the distance between the two is equals to 40 meters, find the center of mass of the system. Center of mass kavali. Direct formula teeskondi. So where are you finding that center of mass from? It keeps a significance. Ade kada? Yes. So e point nunchi, hey, tell me 10 kg, 30 kg, 40 meters is the distance. So if you are taking this as M1, that becomes M2. Later, if you are taking that as M1, this becomes M2. You remember, okay? So if you are taking from left side, direct formula cheppandi, R bar is equals to M2D divided by M1 plus M2. Ade kada? This is my M1, this is my M2. So if I am taking this, M2 will come into the scenario. Ante M2 value cheppandi, 30 into D antara, 40 divided by M1 plus M2 is equals to 10 plus 30. Ade kada? So it is equals to 30 into 40 divided by 40, 40 gone, okay, 30 meters. So from 10 kg, your center of mass is at a distance of 30 meters. Your center of mass is at a distance of 30 meters. This is the center of mass between the two. Always remember, okay, always remember, always, it's a very golden marker. I don't understand which color to do. The center of mass of two objects or లేదా two body system తీసుకోండి. The center of mass of two body system, two mass system is always on the line joining them. Okay, always on the line joining them. Now it does not matter, okay, it does not matter what direction you are taking. I'll take one more question. Cheppandi andariki. So this mass is 10 kg, okay, ekkada vachi this is the line and this mass is equals to 60 kgs. Cheppandi andariki. Center of mass kavali na. Now it's not in x axis or y axis kada. Very good, very good, very good. Go not very good. 30 or minus 10. Good, very good. So I want the center of mass of this system. Cheppandi. Same thing, okay, it's not much different, it's similar. Just tell me the final answer and naku oka reference kuda kavali. Reference ante from which mass is that distance from, okay? Done? Yeah, distance I did not give. Sorry, I'm so sorry. Okay? Geetanjali, I'm sorry. Distance, let us say distance is equals to 100 meters. 100 meters తీసుకోండి అందరికి. You do it. Okay? It's a very simple question and I will try to go through each and every aspect of it. Okay? Good. Okay. చూద్దాం. Go not good. 600 by 7. I believe that's the correct answer. So same process, same formula, okay? Same formula. If you are taking M1 as a reference point, answer will be M2D by M1 plus M2. Leda, you are taking M2 as center of mass, origin, M1D by M1 plus M2 is the answer. Okay? చూద్దాం. Sorry, M2D, అదే కదా. This is my mass M1, right? This is, you can take any mass to be M1, you can take any mass to be M2. So this is my M1 ఉంటే answer will be M2D by M1 plus M2. చెప్పండి, M2D అంటే ఎంత? 60 into 100 divided by total mass 10 plus 60. అదే 60 plus 10. So that means 6000 divided by 70 ante 600 by 7. Good. But only this answer is incomplete. Chuskondi endukante you are writing the answer ade kada, you are not deciding the situation ante okasari answer vachi you again go back to the figure and try to relocate the position of the center of mass. 600 by 7 ante enti rough value cheppura, approximately rough value 600 by 7 ante sir 6 7 ones are 7, 7 8s are 56, 4 remaining, 7 5 ante approximately it is equals to 85.7. From which mass, Ray? From which mass? From which mass? This is my origin kada? Yes. So sir, this is my origin. Ee origin nunchi approximately 85.7 meter ante somewhere here, Ray. 85.7 meters. Ide kada? This is my center of mass. Only calculating answer is not sufficient. Okay? You also must locate the position. Position kuda chala important. Very good. Yes, Gitanjali, very good. Very good, very good, very good. Not 60 by 7, it should be 600 by 7. Chudandi, I don't know where you are doing the mistake. It should be 600 by 7 and 85.7, something like this. Okay? Yes, from 10 kg. Good, very good, very good. So now let us see a PYQ. Okay? Once you are good with all these things, then you see how easy the question looks. Ray. Okay? Cheppandi. Question teeskondi. 3 masses are placed on x-axis. It has directly given you the axis also, okay? It should not be given, but it has given you 300 gram at origin. 300 gram at origin. And one more thing, students, okay? One more thing. If you are not given masses in kgs, you convert them in kgs for simplicity purpose, okay? Next mass is 500 grams at x is equals to 40 centimeters. Leda, you leave it, okay? You do it in centimeter and gram only. And the third mass is 400 gram at x is equals to 70 centimeter. Full stop. Distance of center of mass from origin is dash. Option A, 30 centimeter. Option B, 40 centimeter. Option C, 45 centimeter. And option D is 50 centimeter. Cheppandi andariki. Same thing. Assume 3 masses. Oka place lo origin teeskondi. Okay? No, 60 into 100, Parimala, 60 into 100 becomes 6,000, not 600. Okay? Your calculation mistake is there. 60 into 100 is 6,000. Okay? 6 into 100 is 600, but 60 into 100 is 6,000. Nandini, welcome, welcome Nandini. No problem. Cheppandi. What are the values of center of mass? Okay. So it is same question as the previous one. Previous and 3 masses. Gurtunda, we took 3 masses, right? We changed the origin for each mass. Same question. Okay, x-axis is there. 3 masses unnai. 300 gram, 500 gram and 400 gram. Ade kada distances kuda teeskondi. So ide na x-axis. You want to draw it. Leda you leave it as it is. 3 masses teeskondi. Ade. So the first mass is your 300 gram at origin. So this is your 300 gram mass. Chuskondi andariki. Ade kada at origin. Next, is your 500 gram at 40 centimeter distance. Andariki చూసుకోండి. Next mass is 500 gram at 40 centimeter. అదే కదా? So this is your 500 gram at 40 centimeter. Distance అంటే 40 centimeter. This is my 40 centimeter andariki. From origin. And then 400 gram at 70 centimeter. Ante ide na 400 gram distance. Ade kada? So next mass is 400 gram. The distance is 70 centimeter from origin. Andariki chudandi. So this is my total distance of 70 centimeter. Ade naku center of mass kavali. Good. Very good. 38.3. Chudam. Okay. You assume any object to be origin. Anyone. I don't care. Okay, I don't care. If you want this to assume origin, you can do that. Origin is absolutely personal choice, ra. If you want to imagine origin here, you can do that. No problem. Answer will be same. Confidently attempt the question. Other only condition is you attempt it confidently. Next, you understand. M1 is 300. R1 is 0. I'm assuming origin here. I am assuming here. Okay. M2 is 500 gram. R2 की value ఏంటి రా? R2 is equals to R2 bar is equals to 40. అదే కదా? Yes. M3 value చెప్పండి. ఇదే నా M3 की value. And what is R3? R3 is 70. అంతే కదా? So this is my R3. Formula పెట్టండి. అదే. You only need formula. What is formula, sir? Formula is R bar of center of mass is equals to M1 R1 bar plus చెప్పండి అందరికి. What is the formula? Plus M2 R2 bar plus M3 R3 bar. అదే కదా? Whole divided by M1 plus, I don't know why is it creating mistake. Okay. Divided by M1 plus M2 plus M3. అదే కదా? Yes. చెప్పండి values చెప్పండి. M1 value since you listen. R1 is 0 కదా? R1 is 0. R1 0 ఉంటే gone. R1 0 అంటే this term is gone, right? R1 0 అంతే కదా? M2 R2. M2 value ఏంటి రా? 500 gram. R2 value ఏంటి సార్? 40. I remember. నాకు గుర్తుంది. Plus. Why am I writing plus రే? ఎందుకంటే they are in the right side. They are in the right side. చూసుకో. M2 in the right, M3 in the right. అంటే R1, R2, R3 both are right side. Good. Very good. Okay. Plus M3 value ఎంత రా? M3 I believe it's 400 and R3 is 70. So it's 400 into R3 is 70 divided by total masses. Total M1 plus M2 plus M3. You don't ignore that here, okay? M1 value ఎంత sir? 300, 500, 700. 300, 500, 400. అదే కదా? Yes. So 300 plus 500 plus 400. Little calculation is there, but you can do it. Okay? So it is coming out to be 1200. అంతే కదా? Divided by 5 into 4 అంటే 20,000. చూసుకోండి. Plus 28,000. అదే కదా? So it comes out to be 48,000 అందరికి. Divided by 1,200. 0 gone. అంటే 480 divided by 12. 12 ones are 12. 12 fours are 48. 0 is 0. అంటే 40 centimeter from origin అంటే this point. You can do it in any way. Okay? You can do it in any way. Good. Very good. Not A. Manu, you check yourself. Yes. Answer is B. Next. Center of mass calculate చేసింది కదా? దాని తర్వాత what we have to do? చూసుకోండి రే. Even the complex masses also have center of mass in them. Okay, what I'm telling? Complex masses కూడా center of mass is there. It might be on the object. It might be out of the object. Okay, ఇప్పుడు we will talk about the two-dimensional center of mass. Two-dimensional అంటే ఏంటిరా? చూసుకో. You understand? In all these questions, your masses are along x-axis. అంతే కదా? Total masses are along x-axis. Now, I want to change this, ray. Change ante, let me do some experiment. I'm playing with physics, okay? Good, very good. I'm playing with physics. Playing with physics ante enti, sir? I'm simply lifting this mass. Chuskondi, I'm lifting this mass and I'm bringing it here, ante on y-axis. I'm bringing this mass from x-axis to y-axis. Chuddam, what change will happen, okay? Let us see what happens in that scenario. Andariki, cheppandi. So, ippudu, initially what did happen? Initially, all three masses were on x-axis. Ante kada andariki cheppandi. It's a very important thing. Okay, it has been asked multiple times. So this is my first mass, ide na second mass, ide na third mass. I can do it very easily. I can choose origin R1, R2, R3 తీసుకోండి, అక్కడ నుంచి ఫార్ములా వాల్యూ సబ్స్టిట్యూట్ చేసి your answer is in your hands. ఇప్పుడు I am changing the position, అంటే I am lifting this mass and I am putting it here. Can you see it? I don't think it's visible to you. Okay? So let me just highlight it. So this is my origin. చూసుకోండి అందరికి. So this is my first mass at origin. అందరికి చెప్పండి, ఇదే నా second mass and this is my third mass. అంతే కదా. Now the mass has been changed. So I cannot take the same formula. చూసుకో. What mistakes they do. What mistakes the students do is, I will tell you. Okay? I will tell you. చూసుకో. If I tell you this distance is 4 meters, అందరికి చెప్పండి, this distance is 4 meters and this distance is 3 meters. Masses తీసుకోండి, m1 is equals to 5 kg, ఎక్కడ the mass is 6 kgs and here the mass is equals to 9 kgs. These are the masses. What do you think is the center of mass formula? What do you think is the center of mass formula? చెప్పండి అందరికి. What do you think is the center of mass formula? Sir, R bar center of mass is equals to M1 R1 bar plus M2 R2 bar plus M3 R3 bar divided by M1 plus M2 plus M3. అదే కదా. R1 bar ఎంత రే? 0. M1 5, R1 0. M2 6, R2 ఎంత సార్? 4. Good. M3 ఎంత సార్? M3 is 9. R3 ఎంత? R3 value చెప్పండి. R3 value how much? What is the value of R3? R3 is 3 meters sir. Substitute చేసుకోండి. అంటే now I'll substitute the values. చెప్పండి అందరికి. M1 is 5, R1 0 plus M2 is 6, R2 is 4 కదా, plus M3 చెప్పండి. M3 is 9 into R3 is 3 divided by M1 plus M2 plus M3. 5 plus 6, 11 plus 9 is 20. అదే కదా. So it is coming out to be 24 plus 27 divided by 20. అంటే 51 by 20. అదే కదా. This is the mistakes most of the students do. చూసుకోండి. This is the mistake most of the students do. This is a wrong answer. చూసుకోండి. This is not the correct answer. ఎందుకంటే you are ignoring vectors. కాబట్టి I told you vector is the basic requirement to solve this chapter. Okay? You are ignoring the vectors. You are ignoring the vectors. Student, how will you do this question? Your approach is correct. ఈ formula, this is also correct. కానీ ఎక్కడి నుంచి రెండు మెథడ్స్ ఉన్నాయి రా. You can take any one of you want. Okay? The first method is when you are writing the values of R2 and R3 bar. ఆ టైంలో you are forgetting the vectors. Vectors అంటే ఏంటి సార్? Directions. No, answer is wrong. This is a wrong answer. Okay? So when you are doing the formulations, you have to substitute R2 bar and R3 bar along with their directions. Directions గుర్తుందా? X axis అంటే I cap, Y axis అంటే J cap. So I cap and J cap are there. Understanding? I cap and J cap. You introduce I cap and J cap. అంటే ఒకటే చేంజ్ చేసుకోండి. You just introduce I cap and J cap. Sir, so 6 into 4 I cap, M2 R2 plus M3 R3, 3 J cap. అదే. This is the only change that you have to do. అంతే కదా? Yes. చెప్పండి. So it comes out to be 6 into 4 becomes 24 I cap plus 9 into 3 అంటే 27 J cap divided by 20. ఎప్పుడు you cannot add I and J. Understanding? You cannot add I and J directly. Vectors kada. Are you understanding? It's a vector quantity. So you cannot do the direct addition. 2I plus 3J is not 5. Understanding? So you just understand. ఇప్పటి నుంచి what you have to do is, from this, చూసుకోండి, you separate the numerators. ఎలా separate చేయాలి సార్? So it is 24 I cap by 20 plus 27 J cap by 20. అర్థమైంది అందరికీ? So this is the center of mass. నా R bar of center of mass రా. చెప్పండి అందరికి. అదే కదా. Wanna simplify sir. So it is 6 I cap divided by 5 plus, you can simplify? No, you can't simplify. So keep it as it is. 27 by 20 into J cap. Ante enti, I will tell you now. You understand the meaning of it. Okay? You understand the meaning of it, ra. మీనింగ్ ఏంటంటే సార్ ఐ క్యాప్ అంటే ఎక్స్ యాక్సిస్ కదా, సో యువర్ సెంటర్ ఆఫ్ మాస్ ఈజ్ let us break రే, this is r bar center of mass కదా, so it is your x center of mass, ఇది మీ y center of mass. So ఇక్కడ నుంచి you can simply say sir x coordinate of center of mass it is equals to 6/5 and y coordinate of center of mass it is equals to 27/20. అంటే origin నుంచి x direction లో వెళ్తే your center of mass will be somewhere around 6/5 in x axis చూసుకోండి, and in y axis your center of mass will be around 27/20 అంతే కదా. సో యూ ప్లాట్ ద పాయింట్స్ రే, యూ ప్లాట్ ద పాయింట్స్. సో దిస్ ఈజ్ యువర్ ఫైనల్ సెంటర్ ఆఫ్ మాస్. అందరికి ఇదే మీ ఫైనల్ సెంటర్ ఆఫ్ మాస్ చూసుకోండి, అంతే కదా. దిస్ ఈజ్ యువర్ ఫైనల్ సెంటర్ ఆఫ్ మాస్. ఓకే, అండర్స్టాండింగ్? గో నాట్ యూ డిడ్ దిస్ వే, సేమ్ వే ఆర్ ద రాంగ్ వే. ఓకే, చూసుకోండి. క్వశ్చన్ 3 masses, not 3 masses, ra. Question తీసుకోండి. Are placed as shown, okay, as shown, full stop. Find the center of mass. చూడండి, in this diagram he has directly given you the values అంటే this is my first mass, ఇదే నా సెకండ్ మాస్ అండ్ ఇదే నా థర్డ్ మాస్. డిస్టెన్స్ ఇస్ 2 meters, ఇక్కడ కూడా 2 meters. మాస్ ఇస్ సేమ్, అంటే ఇక్కడ మాస్ m, హియర్ ఆల్సో m, హియర్ ఆల్సో m. ఆప్షన్ ఏ తీసుకోండి. ఆప్షన్ ఏ ఇస్ 2/3 I cap plus J cap. ఆప్షన్ బి is 2 times of I cap plus J cap. Option C is Done. Yes, I'm here. Good. Chuddam. Andariki, very good. If your answer is coming, very good. Cheppandi. Simple formula kada. You assume this to be origin ra. Ekkad nunchi your R1 bar is equals to 2i. Ade kada. And your R2 bar is equals to 2j. Directly put the formula. What is the formula, sir? Sir, R bar is equals to M1 R1 bar. This is the reason why your direction matters a lot. Okay, your direction keeps a huge significance when it comes to finding the center of mass. Plus తీసుకోండి M2 R2 bar plus M3 R3 bar divided by M1 plus M2 plus M3. అదే కదా. R1 bar అంటే origin. This is equals to 0. So ఈ term gone రే. What you are left with is M2 R2 bar. M2 value అంటే M into R2 bar అంటే 2i cap plus M3 value కూడా M multiplied by R3 bar అంటే 2j cap. అదే కదా. Divided by M1 plus M2 plus M3. అదే. So that means 2mi plus 2mj. అదే కదా. So 2mi plus 2mj divided by చెప్పండి divided by M1 plus M2 plus M3. M అంటే 3m. అదే కదా. It is 2m. It does not becomes 4m. Okay. It cannot become 4m. చూసుకోండి. It does not become 4n. Okay. Take m common from numerator. అందరికి m common తీసుకోండి. You are left with 2i plus 2j divided by 3m. అదే కదా. So em gone. What you are left with is R bar is equals to 2i plus 2j divided by 3. 2 కూడా కామన్ తీసుకోండి. 2 కామన్ తీసి you are having i plus j divided by 3. So ఇది మీ R bar అంటే ఆప్షన్ A. Right? చూసుకోండి. Now whoever is having some mistakes, please correct it. Okay? Perfect. ఏదైనా డౌట్స్ ఉంటే చెప్పండి అందరికి. వాట్ ఎవర్ డౌట్స్ యూ హ్యావ్ టెల్ మీ. ఓకే గుడ్. ఓకే చూసుకోండి. నౌ ఐ వాంట్ టు డిస్కస్ అ వెరీ ఇంపార్టెంట్ థింగ్ విత్ యూ. ఓకే, చాలా ఇంపార్టెంట్ అందరికి. గుడ్ గీతాంజలి, వెరీ గుడ్. The most important thing is sometimes in your examination the examiner is giving you rod problems ra. చూసుకోండి. No, we did not add 2. చూసుకో. It is 2i plus 2j doesn't become 4ij. Are you understanding? It's not right. It's a vector. Vector lo you have to add it using resultant of vector formula, root of a square plus b square plus 2ab cos theta. అదే కదా. Okay, don't understand? Let me take it once again. Okay, quickly let us go through the solution. చూసుకో. So this was my first mass m, this was my second mass m, this was my third mass m. అదే కదా. m అంటే m1 value ఎంత? m1 is equals to m, m2 is also equals to m, and m3 is also equals to m. కానీ this distance was 2, this also was 2. అదే కదా. m1 value is equals to m. Once you understand the steps first, all of you who are not understanding the solution, step number 1 is to choose the origin. దాని తర్వాత ఒకసారి ఒరిజిన్ ప్లాట్ చేసినంటే you write the values of m1 m2 m3 r1 r2 r3. okay, vector form lo. Okay, in vector form you understand. So m1 value is equals to capital M, m1 value is capital M, m2 also capital M. అంతే కదా. m3 value is also equals to capital M. ఎక్కడ నుంచి r1 value is 0. చూసుకో, ఇది నా m1 కదా. This is my origin only. So origin నుంచి m1 కి distance is same అంటే 0. r2 చెప్పండి. r2 is in the right side. రైట్ సైడ్ అంటే x axis. ఇదే నా y axis. అంతే కదా. x axis లో distance ఉంటే you write it I cap. So it becomes R2 bar is equals to 2i cap. And similarly, third mass, M3 distance ante in the y-axis. Choose the vectors also, okay? Vectors also. So here onwards, you write R3 bar is equals to 2j cap. Now what you do? You write the formula. Formula is R center of mass is equals to M1 R1 bar plus M2 R2 bar plus M3 R3 bar. Bar ante directions. R1 bar, R2 bar, R3 bar ante directions. Ante kada? Divided by total mass M1 plus M2 plus M3. Ardham chesko. R1 bar is 0 kada. Now I have to substitute the values in it. R1 bar is 0 ante it is gone. M2 value enti M. R2 value enti 2i. Ade kada. Plus M3 value enti again M. Malli M. R3 value enti 2j. Ippudu the value has been changed. Divided by M1 ante M. M2 ante M. M3 ante M. Add them. M plus M plus M. Ade kada. So you can simply say 2im ante 2mi cap. Ade kada. 2mi plus 2mj. Chuskondi. Plus 2mj divided by M plus M plus M ante 3m. 3m. Gone. You can just simplification now. You can simply say M is gone. Your R bar is equals to 2i plus 2j divided by 3. 2 ki common తీసుకోండి. Common తీసిన తర్వాత you simply get with I cap plus j cap divided by 3. Okay. Is it buffering? Buffering. Okay. Good. Next. So now what your examiners are asking is చూసుకోండి అందరికి. Good. You're not understanding. Okay, good. చూసుకోండి. Now. You have center of mass of continuous mass distribution also. Okay, continuous mass distribution also. Take this before that. చేసి ముందు you take it as your homework question అందరికి. Okay, this is your homework question. అంటే ఈ క్లాస్ అయిపోయిన తర్వాత you sit for half an hour. Okay, sit for half an hour in an isolated environment. ఒక chair, ఒక table తీసి you try this, attempt this question and go to the philosophical aspects of it. Nothing more. Okay, not much. Just half an hour will be sufficient. Okay, తీసుకో. So this is my first mass, capital M. This is my second mass, ikkada kuda capital M. This is my third mass. Let us say this is 2m, okay? And this is my fourth mass. It is M. So they are placed along a vertices of a square. Let us say this side is A side kuda A. This side is also equals to A, and this side is also equals to A. Okay? Placed along the side of a square. Center of mass calculate cheskondi. You assume any particle to be the origin. You can assume wherever you want. Kani directions matrame you have to be careful in it. Okay, great. Eppudu, so this was the center of mass of discrete mass system. Chuskondi andariki. What I am telling? This was all about the center of mass of discrete mass system. Discrete ante entira? Vere masses unnai kada. Chuskondi. Here there are 4 masses. Last question lo 3 masses unnai. In that question we had 2 masses. Again there are 3 masses. So where they are separated. Discrete mass system. Okay, discrete mass system. Ippudu let us talk about the center of mass of a continuous mass distribution. Cheppandi. So now I'm going to talk about continuous mass distribution. Continuous mass distribution. Andariki cheppandi. Continuous mass distribution unte your formula M1 R1 bar plus M2 R2 bar plus M3 R3 bar does not hold good. Enduku sir? Continuous masses kada. So you cannot find each and every mass in it. There are millions and billions and trillions of masses our system lo. You cannot find each and every mass and distance kada. Understand what I'm telling to you. Okay, understand. All of you understand. అందరికీ చెప్పండి. కంటిన్యూస్ మాస్ డిస్ట్రిబ్యూషన్ ఉంటే ఫర్ ఎగ్జాంపుల్ రాడ్ రీ చూసుకోండి, నా దగ్గర ఒక రాడ్ ఉన్నాయి. ఓకే, సో దిస్ ఈజ్ మై రాడ్. ఫర్ ఎగ్జాంపుల్ ఐఎమ్ టెలింగ్ యూ దిస్ ఈజ్ మై రాడ్. అందరికీ చెప్పండి. సో దిస్ ఈజ్ అ రాడ్. రాడ్ అంటే తెలుసా? ఎస్. సో సార్ ఈ రాడ్ పై దేర్ ఆర్ ఇన్ఫైనైట్ అమౌంట్ ఆఫ్ పాయింట్స్ ఐ క్యాన్ సే ఫర్ నౌ. ఓకే, so I cannot take M1, M2, M3, M4, M5. It's filled with the points, ra. I can't use that formula now. Understanding? I can't use that formula now. So what do I have to do now is I will have to change the approach. Ante this became complicated kada. So I have to use the formula also. That is a little complicated. Ante integration. Good. Ante eppudu I have to use integration. Integration ante enti sir? Remember the formula. R bar of center of mass is equals to integral of small mass. Because small mass తీసుకోండి. Small mass అంటే ఏంటిరా? Small mass అంటే we represent the small letters with the letter D కదా. Small mass dm, small distance dx, small charge dq, small length dl. Understanding? Okay. So you do one thing. ఇక్కడ you assume origin. ఇక్కడ కూడా origin కావాలిరా. Steps remains the same. Only the formula is changing. అదే కదా. Steps are remains the same. Steps ante enti sir? Origin choose cheskondi. Dan tarvata masses ante distances raskondi. I'll tell you the approach, general approach to find it. Endukante a question has been asked in your PYQs. Okay, so let us take that question also. Andariki jagrataga vinandi ra. Okay, it's a very important thing. Very cheppandi. So here you can assume your origin at this point. You can you can assume it wherever you want. Okay, wherever ekkadaina meeku ishtam, you assume the origin there itself. But I'm assuming at this side. Ante enti sir, idena origin ade kada. Origin assume chesinappudu you assume a random mass, small mass dm. Chuskondi ra, em cheyali ippudu you have to assume a small mass dm. So it is my small mass dm ante chuskondi. This is my small mass ade kada. Yes, this is my small mass dm ra. Cheppandi. So this is my small mass dm sir. Mari em cheyali? Then you calculate the distance of that dm from origin ra. So let us say this distance is x. Ante kada? Yes. What did I do? Na daggara oka continuous mass system unte same process. Step number 1, assume origin. Dan tarvata oka general mass teeskondi. General mass dm teeskunnanu. Dan tarvata distance kuda teeskondi. Let us say the distance is x. Okay, let us say the distance is x. Ante eppudu the formula remains something like this. R bar of center of mass is equals to, ante position of center of mass is equals to integral of small mass dm multiplied by the distance x whole divided by integral of dm. Andariki cheskondi. So this is the formula. You have to remember. Sir, ekkada uchi the variable is m. You remember integration we discussed in basic mathematics ra. Integration lo what did we do? We said that integration cheyadaniki your variables should be same. Ante x square dx chuskondi. X same kada. Kani dm into x unte dm into x ante integral x dm ade kada. Yes, ekkada variable is m and here the variable is x. It is creating the problem ra. Here is the biggest problem. So we will have to tackle with this. So ela tackle cheyali sir? Dani kosam you have to understand some terminologies. Generally very difficult for NEET students. I am trying to simplify them. Okay, vinandi. Total length of the rod kavali ra. It will be given 100% the length of the rod will be given to you. Mass kuda it will be given to you. Don't worry, it will be given to you. So ardham cheskondi. Let us say the mass is capital M ra and the total length is capital L. Andariki ardhamaindi. Total mass is M, total length is capital L. Ade kada? Yes. Total mass is capital M, total length is capital L. Sir, what next? Sir? Now you visualize. Okay, you visualize. Sir, a total length pi, capital length pi, mass M is distributed. Ante kada? Mass M is distributed. Sir, if total length is L and mass is capital M, sir, now question is, what is the mass of 1 unit length? 1 unit ante telusa? 1 unit length. What will be the mass of that? That's my question. That's my question. You imagine it something like this. Okay, all of you. You imagine it something like this. మీ దగ్గర ఒక 10-meter long road is there, okay? 10-meter long road is there. Now on this road, చూసుకోండి, on this road, on 10-meter long road, I am dropping diamonds, okay? I am dropping diamonds. So these are my diamonds. So ఇదే నా diamond pieces, okay? On this road, there are these diamond pieces. For example, let us say there are 200 diamonds on 10-meter road. అదే కదా? So there are 200 diamonds on 10-meter road. 200 diamonds on 10-meter road. చెప్పండి, 1 meter లో ఎంత diamonds ఉన్నాయి? In 1 meter, how many diamonds are there? If in 10 meter there are 200 diamonds, in 1 meter how many diamonds are there? I want the answer. Andari. If there are 200 diamonds, okay, if there are 200 diamonds on this 10-meter long road, in 1 meter, what is the number of diamonds? Cheppandi. Good. 20 meters. How? ఎలా calculate చేసినాం? So sir, we divided this number with this number. అంతే కదా? This number with this number. This number with this number. Same ra. Here there were 200 diamonds. Here there was M mass. Here there was 10-meter length. Here there is L length. అదే కదా? So sir, you came to 20 results. ఎలా calculate చేసినావురా? So you have simply divided this 200 by 10. అంతే కదా? That means you have divided the mass with the length. చూసుకోండి, you have calculated M by L. ఈ M by L వాల్యూ అంటే ఈ కేసులో 20. 20 అంటే ఏంటి సార్? In 1 meter there are 20 diamonds. 2 meters ఉంటే 40, 3 meters ఉంటే 60, 4 ఉంటే 80. సార్ N ఉంటే N meters is the length. N into 20. N into 20 అదే కదా? Yes. So sir, for 1 meter there are 20. Ante for 1 meter, for 1 unit length, okay, for 1 unit length there are M by L. For 2 unit length there are 2M by L. Ante kada? For 3 unit length there are 3M by L. And for dx length, చూసుకోండి, this length is dx kada? Yes. So for this dx length, multiply, sir, dx into M by L. So this is the number of diamonds. Ante the mass that is there in this dx thickness. చూసుకోండి. Okay, if you are understanding that, very good. If you are not understanding that, remember, గుర్తుపెట్టుకోండి formula, just you remember the formula, okay? So sir, total length L is there, total mass capital M is there. So in the thickness, small thickness dx, small mass, chinna mass dm is equals to, understand, total mass per length multiplied by the thickness dx. Ide. So ide dm ki value, I'll lift it and I'll substitute here. Ante kada? Yes, you have to do it. Cheppandi. So now what you understand is, sir, r bar of center of mass is equals to integral dm into x. dm ante enti ra? Capital M by L into dx multiplied by x. Ante kada? dm into x whole divided by, again malli dm integral ra, dm. Now this is the most important result ra. Okay, this is the most important results. Okay, this is the most important results. Cheppandi. So now what I'll say is, r bar of center of mass is equals to integral of M by L into dx into x. M by L into dx into x divided by integral dm. Integral dm ante enti ra? Integral dm ante చిన్న dm ki addition. So total addition చేసిన తర్వాత, don't you get capital M mass? Yes, you will get it, capital M. Integral dm is capital M andariki. So that is coming out to be integral M by L into dx multiplied by x divided by capital M. అదే కదా? కామన్ వాల్యూస్ ని బయటికి తీసుకోండి రా, ఇంటిగ్రేషన్ సైన్ నుంచి బయటికి తీసుకోండి. సో యూ కెన్ సింప్లీ సే M by L into integral x dx divided by integral M. అదే కదా, m gone. So what you're left with is 1 by L into integral of x dx. Limits చూసుకోండి అందరికి, limits of integration. Your first particle starts from x is equals to 0 and your last particle is at the length x is equals to capital L. అదే కదా? Yes. Your first particle starts from x is equals to 0 and the last particle is x is equals to capital L length. So you substitute the limits. So 0 to capital L. అదే. So you are left with 1 by L into integral x to the power 1 రా. ఇంటిగ్రేట్ చేసిన తర్వాత you are left with x square by 2. అదే కదా? లిమిట్స్ పెట్టుకోండి. అదే. So this is equals to 1 by L into, చెప్పండి అందరికి, L square by 2. అంతే కదా? Yes. So L gone. What you are left రే? L by 2. అంటే ఏంటి సార్? అంటే we did all this headache and the final answer came as L by 2. అంటే the center of mass of a normal rod is at the center of it. L by 2 అంటే center point కదా? Yes. So this is the center of mass of the rod. అంటే ఒక రాడ్ ని తీసి, రాడ్ I don't have it, you know, that's the biggest tragedy. Okay? I hope it's visible to all of you, right? This is a rod రా, చూసుకోండి. This is the rod. Now, how do I find the center of mass? Hey, చూసుకోండి. Now, to find the center of mass, you do this experiment at your house, okay? Slowly bring your fingers to close to the rod. Sometimes it's very thick and sometimes it's very thin. చూసుకోండి. Slowly, you bring your fingers towards the center of the rod. చూసుకోండి. It's not falling, right? It's not falling until this is the center of mass of the rod. Can you visualize? This is the center of mass of the rod. చూసుకోండి. You do it just like this. అందరికి చెప్పండి. Are you understanding it? You take a long rod. It's a very short rod, but మీ ఇంటికి there might be a bigger rod. So తీసుకోండి and slowly bring your fingers close to this rod. Okay? Close to this rod. All the times you will get the center of mass. Okay? This is the best way to find the center of mass of any rod. Okay? Of any linear object. But if I am trying to find it, coming, right? Not buffering. Okay. Yes, Nandini, I also don't know, you know. But I think it's coming from my end, right? Good. Please check your networks, okay? Please check your networks. If from your side it's the problem, from my side I'm not buffering. At least I can tell you. See, all the video is clear from my side. Okay? No buffering at all. Everything is clear. Okay? From your side you check it. Yes, very good. Yes. If it's a uniform rod, then the center of mass will be at the center. Okay, if it's non-uniform rod, then you will have to change your approach. Okay, let us see that question also. Okay, I'm taking that question also. It has been asked PYQs. I don't know which PYQs, but I've just seen it. Okay. Hey, one more thing. Okay, one more thing I want to tell you. Okay. So this is the rod. Ante kada. You imagine it's a rod, right? Don't have the rod. That's the biggest problem. Okay. You imagine it's a rod, right? Yes, 8 or 8:30. Nago teliyadu, Nandini. Maybe 8 or 8:30. Okay? Possibly 8:30. You imagine, okay, if this is your rod, and if this is your center of mass, okay, the rod is balanced, kada? Yes, the rod is balanced. That means if I keep the rod something like this, చూసుకోండి, on the center of mass only. I don't know if it will be balanced or not, but I hope it gets balanced, something like this. చూసుకోండి. It's very difficult to understand. Okay. So this is the center of mass kada. Now what I'm doing is I'm trying to rotate it and I'm trying to hit it. Okay, you understand this, all of you. You understand, all of you. Understand. If I'm hitting it very slowly and at the same time, చూసుకోండి, at the same time, if this point is not displacing, ante if the rod is fixed on this point, you move it, it will easily move. Ante the rod will keep rotating, something like this, but it must be set on the center of mass of the rod. Okay, then and only then the rod will move. Okay, with exactly on the same point. అర్థమైంది అందరికీ? Okay, so if at all you have to rotate this rod just by supporting at a single point, that single point must be the center of mass of the rod. Okay, right. Same question. Okay, same question has been asked. Question తీసుకోండి. Okay, point masses m1 and m2 m2 are placed at opposite ends of a rigid rod. So this is the figure. This is the figure. Okay, this mass is m1. This mass is m1, and here is another mass m2. Ante kada? Yes. So this is the axis of rotation. This distance is x, and ఈ మొత్తం distance ante l minus x. ఎందుకంటే length of the rod is l ante kada. So now You have option A, x is equals to m2 by m1 into L. Option B, x is equals to m1 by m2 into L. Option C, x is equals to m1L divided by m1 plus m2. And option D, x is equals to m2L divided by m1 plus m2. No, I did not make it. It has been asked in NEET examination. Looks too complicated, right? Too complicated, but it is just telling where should I place such that it rotates. That is the question, Ra. It rotates. Finish. Vorsu Mallesh. I'm telling that only. You have to be good. Theory based question is not sufficient in your examinations. Kada? It is just telling me to find the center of mass. Center of mass. Two mass system is there, Ray. Two mass. You remember I told you, just now I told you. If you have a two mass system, మీ దగ్గర టూ మాస్ సిస్టమ్ ఉంటే దిస్ ఈజ్ యువర్ ఫస్ట్ మాస్ m1. ఓకే చూసుకోండి, దిస్ ఈజ్ యువర్ ఫస్ట్ మాస్ m1, దిస్ ఈజ్ యువర్ సెకండ్ మాస్ m2 రా. సెంటర్ ఆఫ్ మాస్ ఆఫ్ ద సిస్టమ్ ఇస్ బిట్వీన్ టూ, అంతే కదా. వాట్ ఈస్ ద వాల్యూ ఆఫ్ సెంటర్ ఆఫ్ మాస్ చెప్పండి. వాట్ ఈస్ ద వాల్యూ? గుడ్. The value of center of mass from m1 is equals to m2d divided by m1 plus m2. D ante distance of the length. And from this m2 is equals to m1d divided by m1 plus m2. Ade. Where is it asking from? m1. What is the total length? L. Chappu. So if it is asking from m, it should be m2 into total length divided by finished. Go. Okay. Very simple question, right? Very simple question. Okay. Next. Student. Now, let us mix all together, okay? All of it together. Together ante enti ra? Let us mix all of it together. Together ante enti? I have discrete plus continuous mass distribution. Okay, I have discrete plus continuous mass distribution. చూసుకోండి. అంటే ఏంటి సార్? Discrete plus continuous mass distribution కదా. అంటే ఈ సినారియోలో you have collection of set of values. అంటే చూసుకోండి. So I have a rod, the length of the rod is L. Okay, this rod pai I am suspending two masses. So ide na first mass M1. Chappu. Mass of the rod is capital M. Andariki. And this is my second mass M2. Ante kada? Yes. I want to find center of mass of rod plus mass system. చెప్పండి అందరికి. So that means it is continuous also and it is discrete also. Continuous ekkada sir? This rod is continuous. చూసుకోండి. ఇదే నా continuous mass and these are my discrete mass. How will I do it? చెప్పండి. నో, చాలా కన్ఫ్యూజింగ్ కదా సార్. దేర్ ఆర్ 3 different ఆబ్జెక్ట్స్. ఎలా ఫైండ్ చేయాలి, ఏం చేయాలి, హౌ టు డూ ద అప్రోచ్ అండ్ ఆల్ దీస్ థింగ్స్. చూసుకో. How many of you remember in the beginning of the lecture I told one thing. What, sir? The moment you calculated the center of mass, understanding, the moment you calculated the center of mass, take that center of mass, ఆ point లో concentrate the entire mass of the object. అదే కదా? Yes. ఆ point లో you calculate the entire mass. అదే. So that means it's a linear rod ray. అంటే ఈ రాడ్ కి మాస్ క్యాపిటల్ M, it is entirely focused. Listen to me. అందరికి listen to me. The length of the rod is capital L, mass is capital M, కానీ the center of mass will be somewhere in the center of the rod కదా. Agreeing? Good. So now ఒకసారి center of mass of rod calculate చేసిన తర్వాత you understand the total mass of the rod is focused only at that center. అంటే ఈ మొత్తం రాడ్ కి ప్లేస్ లో ఐఎమ్ జస్ట్ రైటింగ్ అ సింగిల్ పాయింట్ అండ్ ఐఎమ్ టెలింగ్ ద మాస్ ఆఫ్ దట్ పాయింట్ ఇస్ క్యాపిటల్ M. అదే. సో వాట్ హ్యాపన్స్ డ్యూ టు దిస్, సార్? డ్యూ టు దిస్ యువర్ ఎంటైర్ హార్డ్ వర్క్ ఆర్ కన్ఫ్యూజన్ ఇట్ గెట్స్ రెడ్యూస్. చూసుకో. సో అంటే రాడ్ ఇస్ గాన్. ఇట్స్ అ సింగిల్ పార్టికల్ కదా. అండ్ హియర్ ఆల్సో దేర్ ఆర్ జస్ట్ ద పార్టికల్స్ రే. చూసుకో. సో యువర్ M1 is a mass, it is here. మీ M1 is here and your M2 is here. అంతే కదా. Got it. Single masses kada, discrete masses ఉన్నాయి రా. So you can simply take their positions to be on the rod. ఎప్పుడు చూసుకో. 1 point, 2 point, 3 point. అదే. Simplified a lot simplification is there. Understanding, can you find now? It's a very easy process. అంతే కదా. Are you understanding? Should I explain it once again? Tell me. So what did you have? Initially మీ దగ్గర ఒక rod was there, right? Yes. Length was L, mass was L. ఈ rod పై, okay, if you are getting confused by the diagram, let me just remove the diagram ra. I'll give you simple case version. చూసుకో. So this was my mass M1 and this was my mass M2. అందరికి అదే కదా. Yes. Mass of the rod is capital M. Two masses are placed on the rod. నాకు center of mass కావాలి. అదే కదా. Yes. So how will you find the center of mass? That's it. So to find it, this rod is creating a problem. Similarly, all the shapes like the rod ray, disc, semicircular disc, ring, they are creating too much problem. Ante kada. So the best thing that you can do is directly calculate their center of mass and consider the entire mass capital M is just focus at their distance. Ade. So if you are calculating it, this will be gone. This all rod will be gone. Okay? This gone. ఎప్పుడు డిస్టెన్సెస్ గుర్తుపెట్టుకోండి. ఓకే, డోంట్ ఫర్గెట్ ద డిస్టెన్సెస్ రా. ద సెంటర్ ఆఫ్ మాస్ ఆఫ్ ద రాడ్ ఇస్ అట్ ద సెంటర్ కదా. సో ఈ డిస్టెన్స్ automatically comes out to be L/2 and this distance also automatically comes out to be L/2. ఎప్పుడు M1R1 bar origin is the first choice. Origin choose చేసిన తర్వాత you have to apply M1R1 bar plus M2R2 bar plus M3R3 bar divided by M1 plus M2 plus M3. అదే అంతే కదా. రైట్. Good. Same approach. Okay, all of you, I'm telling you the same approach. So let us take a PYQ ra. Okay, చూద్దాం. It's not there in PYQs. I'll take it. Okay, I will take it. Chances high ఉన్నాయి రా, కానీ అర్థం చేసుకోండి. I think it should be in the continuous. Yes. తీసుకోండి. Okay, I'll just give you the question in the written form. This one, a rod of mass 10 kg and length 20 meters has two different masses. M1 is equals to 4 kgs kept meter కదా 2 meter I'm making it by myself, okay, and another mass 4 kg. Let us take it 6 kgs at a distance of 6 meters from right end. Cheppandi. Do it. It's a very good question, okay, actually. Bhanu, the class will be for complete one shot. It's one shot kada. So it will be continuing till your syllabus gets over. Chapter gets over. Okay? Mostly till 8:30. Okay, 8:30. Mostly till 8:30. Okay. So you might see a gap. Hey, all of you, listen. You know, I have to. I do have some work. So, 2-3 days later, there will be a gap of at least a week. Okay, for 1 week, I will not be available. So the classes will be paused. Then tarvata we will continue it. We will continue from the same point where we left. Who is listening to chat? Hey, all of you students, please like the video, okay? Like the video, all of you. Yes, Gunat. There will be a gap, okay? So you will get a break for my class for 1 week. Mm-hmm. 9.6 meters. From what side? Okay, let us see. Okay, let us see. Okay, a rod of mass 10 kg, length 20 meters kada. Yes, so ఇదే నా rod రే అందరికి చూద్దాం. So this is my rod. Mass ante 10 kg, length ante mass is 10 kg, length is 20 meters. Okay. So ఈ length ante 20 meters and mass is equals to 10 kg. Capital M is equals to 10 kg. అదే కదా? Yes. Two masses are there, 4 kg and 6 kg. Okay. So 4 kg mass ఎక్కడ ఉన్నారు? 4 kg, right? And 6 kg is somewhere here. This is 6 kg. Values చూసుకోండి. At a distance of 2 meters from the left end. అంటే this distance is 2 meters అందరికి. అదే కదా? Right. And another at a distance of 6 meters from the right end. అంటే this distance is 6 meters. All of you. Visible, right. నాకు center of mass of system కావాలిరా. How will I find it? Hi, Bharat, hi. I did not see. Hi, Bharat, with a hi. So, first of all, to calculate the center of mass, నాకు center of rod కావాలిరా. అదే కదా? Yes. I want yes. So I want the center of the rod at the center. అదే కదా? So అంటే this distance is 10 meters. చూసుకోండి. This distance is also equals to 10 meters. Okay. దీంట్లోంచి 6 meters has already come కదా? So this distance now, it is equals to 4 meters. అందరికి చూడండి. And this distance, total 10 కదా? 10 నుంచి 2 already వచ్చింది. So it is equals to 8 meters. అదే. So ఒకసారి ఈ distance రాజ్ తర్వాత, are you saying something? Okay. So once you have done with these distances, you convert the whole system into point masses. ఎలా చేయాలి? Rod ఉంటుంది కదా? So you take the center of the rod and focus the entire mass of the rod on that center only. అదే. You take the center of the rod and focus the entire mass of the rod on that center only. చూసుకోండి. This is the center of the rod కదా? So this becomes my rod mass. How much is it? 10 kg. అదే. Good. అంతే కదా? Yes. So from this center of the rod, tell me the distances. First distance is 8 meters. అంతే కదా? Yes. So first distance is 8 meters. 8 meters from the rod. Mass ఎంత సార్? Mass is 4 kgs. Yes. 4 kg mass, 8 meter distance. Here, tell me mass how much? Mass is 6 kgs. చెప్పండి అందరికి. So mass is 6 kgs. And distance is how much? Distance is 4 meters only. అదే. These are my 3 masses. I can easily calculate it, right? Yes, I can easily calculate it. Good. Very simple process. Take someone as origin. So I'm considering this to be origin, okay? I'm considering. ఎందుకంటే sir, I only have the information about the rod. So in my final answer, I will include center of mass of the system from the center of the rod. Okay, so this is my origin, okay? Yeah. So this is the center of the rod. Now distances చెప్పు. Distances అంటే R1 value R1 is in the left side. అంటే R1 bar is equals to -8 and R2 bar is equals to 4. అదే కదా? +4. అదే. And no, R2, it's not R3 R2 is equals to 0. R2 is equals to 0. అంతే కదా? Yes. R3 is 4. చెప్పండి. Values. Just value substitution now. That's it. So you can simply say R bar of center of mass is equals to M1 R1 bar plus M2 R2 bar plus M3 R3 bar divided by M1 plus M2 plus M3. అంతే కదా? Yes. చెప్పండి. M1 అంటే ఏంటిరా? M1 is 4 kg. R1 bar is -8. So sir, 4 into -8 plus 0. It's 0, right? Because R2 is 0 0 plus M3 value ఎంత sir? M3 is 6 kg into R3 is 4. అంతే కదా? So 6 into 4 చెప్పండి. 6 into 4 divided by total mass. 4 plus 10 plus 6. అంతే కదా? So it's -32 plus 24 divided by how much? 20. And it is minus 8 by 20, that is equals to minus 2 by 5 from the center of the rod. Minus ante in the left side kada. So this is the center of the rod and it is minus 2 by 5 and minus 0.4 meters. Very close to the rod but towards the left side. Very good, Bhanu, very good. From 10 kg ante from the center of the rod, okay? From 10 kg ante center. Endukante mass of the rod is 10 kg kada. Mass of the rod is 10 kg, but I have replaced the rod with a point mass. Ade. So the entire trick behind this question was you must be able to replace the complex masses at their center of mass. Ade. Okay, very good. Go not very good. No, where is IJK? No IJK. Everything is in the x-axis only, na? Go not. IJK, where is IJK? IJK ante everything is I, na? If the masses were above and below, then J would have come. Okay? All masses are in a straight line. So straight line ante everything is in I cap. Okay? Next. Good. Now understand, okay? Applications of center of mass. Chuskondi andariki. Now we are going to a little conceptual doubts, okay? Conceptual points ra. Conceptual points. Andariki chudu. Oh, right. I plus J no, in that also is you will have to resolve the third value. You took the resultant kada, root 2a. You resolve that root 2 into I and j. So you will get I here, j here. So it will become 2 times of I plus j. 2a times of I plus j divided by 4. Okay. Final answer is that 2 times of I plus j divided by 4. I am telling you direct answer. Okay. Hey, understand the applications of center of mass. Actually, it is important for JEE, okay? JEE, especially JEE advanced key. I can see one question is there in your NEET 2015. Okay, understand very carefully. Applications of center of mass. It is actually there for JEE. I have taught it for JEE advanced. Okay, very deep applications are there. Kani, there is a question in your NEET 2015. Kabatti cheptunnaru chuskondi andariki. Okay? Let us see, Bhanu, let us discuss on that later. For now, let us stick to this part. Chusko. Number one application is what? Chusko. Number one. I'm going to tell you a situation-based scenario. Andariki artham cheskondi. Okay, you imagine you have a rod ante telusa, very thin rod. Very thin ante massless rod is there. Very thin. Mass is negligible. Of that rod, mass is negligible. Ante kada. Now what you are doing is, a rod ki you are attaching two different masses, okay, two different wheels. So this is my first wheel, this is my second wheel. Andariki artham cheskondi. These are the two wheels, okay? Understand very carefully, okay? It's a very important topic, all of you. మీ దగ్గర ఒక rod is there, very thin rod అంటే massless rod is there, and on the massless rod you are attaching two wheels. Wheels అంటే తెలుసా? Yes. ఇప్పుడు if I hit this wheel, how should I tell you? I don't even have the rod, right? I don't have the rod. Just So this is your rod, okay? This is first wheel, this is second wheel. Two wheels are there, Ray. Can you visualize? I don't have the system at all, Ray. Understand? Okay, understand. I don't think we'll be able to demonstrate it. Can you understand? Try to understand, okay? Hey, tondaraga chusko underiki. So if this is the first wheel, this is the second wheel, okay? I hope you are understanding, Ray. Hey. Like this. So these are the two wheels. Can you visualize? Hey, it's a black one, okay? It's a black one, so you can't see it. It is red and it is black. Okay, these are the two wheels. Wait, hold down. And if I place this system on a rough, smooth horizontal surface, chusko. And if I'm placing it on a smooth horizontal surface like this, okay, I'm placing it on a smooth horizontal surface like this, and I'm hitting it. Any one point you hit it. Hit ante impulse. We'll discuss on that. Hit. You hit it. What will happen, Ra? What will happen? Cheppandi andariki. What will happen if you hit the rod? What will happen? So if you hit it, what will happen? Emaitadi? It will perform circular motion. How? Something like this. You hit it, it goes round and round and round. Are you understanding? So masses of the wheels, M1, M2, all of you listen to me very carefully, okay? All of you. If the masses of the wheels are M1 and M2, the rotation will happen about the center of mass. Ante, this will be the axis of the rotation. Are you understanding? Yes. This is the first application. Second application, andariki chudandi. Second application. If you have attractive forces ante entira. If you have attractive forces, for example, gravitational force. Attractive force kada, two objects ki between. Gravity, leda, you talk about electrostatic attraction, positive charge, negative charge attraction. Right? Yes. Good. Yes. So that will be the attraction forces, right? So let us imagine andariki, it is my mass M1 and this is my mass M2 ra. Okay? Let us say the distance between them is R. Attraction is there. So I release these two objects. Ante kada, I release these two objects. So as soon as I release these two objects, they will attract. They'll hit one another, right? Where will they hit? What position? What place? No. Circular motion does not happen due to center of mass, Gonat. Circular motion is happening because I am kicking it. Okay, some external agent is there. Some external agent oka force exert chestunnaru. Ade. So if you are hitting it or punching it, you are kicking it, or you are, simply tickling it, something like this. Okay? If you are hitting it, it will perform circular. But when you see that circular motion, the center of that circle will be at the center of mass. Okay? If you see this, the rod is moving actually. Okay? The rod is moving. But when I'm seeing this rod from the topmost point, I see the center of that motion is at the center of mass. Okay? And this mass will move in this circle and this mass will move in this circle. Okay? Complex motion. You don't have to go in that much of detail. But just understand this. In case low, when you have two different masses, you release it, they'll attract, they'll meet. Where will they meet? At the center of mass of their positions. Okay? At the center of mass of their positions. So these two masses will meet at the center of mass of their positions. Leda. If there are repulsive forces and positive charges, they'll try to repel. Keda? Yes. So at each and every point, at each and every time, wherever they go, their center of mass will remain the same. Applications of center of mass. Okay. So let us take a question. It has been asked in NEET 2025. Okay. Two spherical bodies of masses m and phi m. your 2015 paper is it's a very complicated, you know, it's not as easy as I'm seeing the questions from center of mass. Although questions are easy, kani చెప్పండి. So after this we'll take a break, okay? How did fever came, Isha? Suddenly fever. You can't risk your health, okay? So exam daggara May kada. So from mid of the April itself, you start taking extreme care of your health, right? Yeah. చూద్దాం. Mass is m and 5 mra, okay? Radii r and 2r. So this is my first mass, radius r is there and mass is capital M. Ante kada. This is my second mass, 5m, and the radius is 2r. Ide. Ante kada. Now. Understand. The radii is getting confused. Ante kada. So what did I say? Okay. I told you, instead of these complicated masses, you can replace it. So ante ఈ masses ki center of mass గురించి చెప్పండి అందరికి. So ఈ masses ki about this sphere, the center of mass is exactly at the center, అదే కదా? Yes, center of mass of a sphere is exactly at the center of the sphere. And here also you can simply say the center of mass is at this point. అంటే ఏం చేయాలి ఇప్పుడు? That means you forget everything about this mass. ఈ మొత్తం complex scenario I don't want it, okay? And here also I don't want this complex scenario. అదే just remember the radius because they will be useful for us in the later parts ra. కానీ for now ఇప్పుడు కోసం you just remember the mass is m, ఈ mass అంటే 5m, అదే కదా? Yes. What is it telling, Ray? Between their centers is 12r. Initial separation between their centers, ra. It is the initial separation between their centers. How much, sir? 12r. Ante kada. Simplification only. Okay. 12R is the separation. Center of mass kavali. Center of mass ante sir, two mass system, shortcut. M2D by M1 plus M2 kada? Yes. M1, M2. And directly you can say M2D, D ante enta 12R divided by M1 plus M2 ante M plus 3M is equals to 4M. Other M gone, 4 ones are 4, 4 threes are 12, ante 9 meter of distance has been traveled. Ante kada 9R re, 9R. Okay? 9R of the distance is the center of mass. Ee mottam distance ante 12R. Ekkad nunchi 9R distance will be somewhere here ra. Ide kada. So if it is 9R ante this distance is 3R. Andariki chudandi. And this is the total distance of 9R. Ide kada. Yes. This is the total distance of 9R. What is it telling? Due to gravity, then the distance covered by the small body before the collision. This is the center of mass. Until the collision is going to happen here. Are you understanding? The collision is going to happen here. That means if there were the small particles only, not 10R, not 10R, it should be 9R. 9R, nare? M2D divided by M1 plus M2, it should be 9R, right? Why 10R? Why are you telling 10R? 5 meters, mass is 5. Oh, sorry. Hey, I did 3, Ray. I was assuming it to be 3. See. I only got confused. Good. Very good. All of you, very good. So it should be 5M, Ray. So answer changes, okay? A little. So it is the 5M mass. Good, very good. Andariki, very good. So M2D ante 5M multiplied by D ante 12R divided by M1 plus M2 ante 4M. Ide kada? M1 plus M2 ante 4M. M gone, right? Okay? 4 ones are 4. It should be 6M now. 6M, right? 6M, yes. 6M ante 6 ones are 6, 6 twos are 12, ante 5 into 2 ante 10R. 10R is the distance. From this M ray, ante this automatically comes out to be 10R. Right? 10R, and this point comes out to be 2R. Right? Yes, 2R. This is the position of the center of mass. And when they will hit at the center of mass. How will they hit, sir? The first sphere will be something like this, and the second sphere will be something like this. And this is the position. Understanding? Yes, good. Mystery is good. Okay, so this is the distance. So that means I have to calculate how much of the distance has been covered by the small mass. Small mass ante radius r, this distance is 2r. Ade kada? Total distance how much, sir? Total distance is 10R, 2R, 12R kada? 12R, right? Good. So the radius of this sphere is 2R. Radius is 2R. Radius 2R ante entira? Radius is equals to 2R. Ante, sir, what does it mean, right? Sir, radius is 2R. R plus 2R, 3R. How are you saying R plus 2R is 3R? Yes. Nandini will be taking the break at 6:15. Okay, 6:15. Break at 6:15. Okay, all of you remember. The question tarvata just going to take it. 40. Hey, you would come at this point now, okay? So if the radius is 2r, release the separation center 12r, attract one another with due to gravity. Center covered by small body before collisions. Kada? Should be a little less ray. Good evening, Maitri. Good evening. Okay, 45. Okay, 45. Cheppandi. I'm thinking if we can do it with this method, okay? There is one more method actually, but I have not taught you. I have not taught you that. Distances covered should be equals to the same distances. And m1 x1 should be equals to m2 x2. Ade kada? Yes. So m1 x1 should be equals to m2 x2. Even if you understand that, Ray, you understand now, okay? All of you, you're there. Hi. All of you, hi. Initially, this sphere was at this point, and this capital, another bigger sphere was at that point. Chudandi andariki. Okay. Okay. So let us say this was, this sphere was somewhere here. Radius, sir, radius how much, sir? Radius is r. Already r distance is covered, right? How much more it has to cover? How much more it has to cover? Cheppandi andariki. How much more it has to cover? This is the total distance of 10r. Cheppandi andariki. It's just mathematics now. Everything is over. Eh? The total distance is equals to 10r. ఈ 10r నుంచి r distance already the boundaries of this sphere are covering. అంటే the total distance it has to cover now is 9r. ఇదే కదా? Yes. 9r. అదే కదా? But when I don't know if I could. Yes, good. Chuskondi. When this sphere is coming here, Cheppo, how much distance it has covered? How much distance it has covered? When it is coming at this instance, Cheppandi andariki. It's actually a very good question. When it is coming at this point, how much distance it did cover, Ray? How much distance it did cover? No. Not 9 minus 2r. See, it has only covered this r distance. Can you visualize? It has only covered this r distance. It has only covered this r distance, andariki. Only r distance. So when it is going again forward, it is again covering r. When it is again going forward, it is again covering r. So such r, it has to cover and go till 9r distance, 9r distance. And total distance is 9r and total diameter is 2r. Diameter, not radius. Diameter is 2r. So sir, can I simply say it will make 4.5 such transitions? Ante one transition, r distance complete. Second transition, r distance complete. Third, fourth. 4.5 transition tarvata, it will reach this 10r distance and it will collide with it. If you are understanding, well and good, okay? If you are not understanding, then leave it. Because it was asked in your examination, I was telling you, okay? Done. Okay, so shall we start, all of you? Hi, hi, hi. Hello, 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 hello. Done with the breaks, right? Okay, 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 okay. So now let us talk about now let us talk about the motion of the center of mass. Okay? ఇప్పుడు let us talk about motion of center of mass. Last question we discussed about it, and in this class చూసుకోండి. So very good important topic. Okay, actually I'm telling you, be very careful. Okay, be very careful. Okay, next let us see. Hi, 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 hi. Good evening, good evening, good evening, all of you. Good evening, good evening, good evening. Motion of center of mass in the sense you understand. Okay, I can classify the motion due reasons. Okay, reasons చూద్దాం అందరికి. So if the reasons, no, EM waves will be for tomorrow. That I've told to the technical team it had to be scheduled for tomorrow, but they have scheduled it now itself. Okay, I think I will have to tell them to delete it. Students are joining there also. Okay, nobody's EM waves for tomorrow, 6 p.m. tomorrow. EM waves. Okay. Hi, Kanmani. I'm good. Motion of center of mass. And let us talk about the reason behind the motion, right? So reason could be force. Ade kada? Yes. Force ante enti, sir? Force in the sense you understand. Newton's first law of motion tells us that whenever the object is at rest, and if we have to bring it in motion, అందరికి చూడండి, ఆ కేసులో ఒక ఎక్స్టర్నల్ ఫోర్స్ కి రిక్వైర్మెంట్ ఉంటుంది కదా. ఎస్, ఒక ఎక్స్టర్నల్ ఫోర్స్ కావాలిరా. ఓకే, ఒక ఆబ్జెక్ట్ ని రెస్ట్ నుంచి మోషన్ లో కన్వర్ట్ చేయడానికి మీకు ఒక ఎక్స్టర్నల్ ఫోర్స్ కావాలి. వితౌట్ దట్ ఎక్స్టర్నల్ ఫోర్స్ ద ఆబ్జెక్ట్ కెన్ నాట్ మూవ్. రైట్. ఎస్, గుడ్. Understand. Now understand. Okay. So force could be classified into two categories. From center of mass, frame of perspectives. So from center of mass perspective, a force could be classified into two different categories. Category number one is the internal force. Are you understanding? And the second one is the external force, right? Yes. So these are the categories of the forces. So first could be your internal force, leda it could be your external force. Understand, students? Okay. Hi, Rani. Hi. Okay. When the force is internal, చూసుకోండి. When the force is internal, force gives rise to acceleration. యాక్సిలరేషన్ నుంచి స్పీడ్ వస్తుంది, స్పీడ్ నుంచి డిస్ప్లేస్మెంట్ వస్తుంది. అంతే కదా? యు అండర్స్టాండ్. ఫోర్స్, యాక్సిలరేషన్, స్పీడ్, డిస్ప్లేస్మెంట్. అదే, అండర్స్టాండ్ ఇట్ ఆల్ ఆఫ్ యూ. ఓకే. సో ఇఫ్ ద ఫోర్స్ ఈజ్ అన్ ఇంటర్నల్ ఫోర్స్, అండర్స్టాండ్, నో ఎఫెక్ట్ ఆన్ సెంటర్ ఆఫ్ మాస్. ఓకే, నో ఎఫెక్ట్ ఆన్ సెంటర్ ఆఫ్ మాస్. A very important statement. Okay, I personally can frame at least 1000 questions only on a single concept. understanding. It's a very deep understanding, right? It's a very deep understanding. You understand? That means, if at all, hi Gitanjali, hi. If at all your forces are internal forces, that's it. Forces internal unte, no effect on the center of mass. And the center of mass remains at rest. Even if you see the system moving, even if you see the system moving, even if the objects or the elements are moving, the center of mass will not move. And the center of mass remains at rest. Yes, very good. The second scenario is the external force. External force unte, you can directly write Newton's second law. What is the Newton's second law, sir? Net external force is equals to total mass of the system. Total mass తీసుకోండి. దాని తర్వాత you can simply say it is equals to acceleration of the center of mass. అదే acceleration of center of mass. మీకు గుర్తుందా Newton's chapter లో when I was explaining you the same Newton's second law, I told you on the center of object కదా, but here I am telling center of mass. Yes. అంటే if you have a force, మీ దగ్గర ఒక force ఉంటే that value of that force is total mass of the object times the center of mass acceleration. I will explain every single thing in detail. The only thing is I request all of you to understand. Understand. Okay. So let us see first case case number 1. Case number 1 ante enti sir? Case number 1 ante the force is an internal force. Force is an internal force. Internal force ante enti ra? Internal force. Okay. You have seen that Bahubali picture, right? A picture lo the Kalikeya versus Bahubali fight. What happens? This guy Kalikeya keeps on collecting people and throws at Bahubali, right? Yeah, it picks the people and throws at Bahubali. Okay. And what does he do? Prabhas, he simply explodes all of them, right? Explodes all of them. Are you understanding? Are you listening to me? Okay. So this is our Prabhas. These are some random people thrown at him ra. Andarki chuskondi. So this is the first person. This is the second person. This is the third person. This is the fourth person. This is the fifth person. And all these people are collected. Ante enti ra? Ante the center of mass of all of them. The center of mass of all the people. Let us imagine that center of mass is somewhere here, okay? Somewhere here. Center of mass is somewhere going to fly now, okay? These are going to fly now. So all the motion is happening due to an internal force. Internal force ante enti ra? Prabhas himself is applying the force internal. Right? Yes. So that means even if they are falling apart, even if you can see the people moving, the center of mass is not moving. Buffering. Is it buffering? It's not buffering, right? It's there, it's coming, right? It's not buffering. Don't say it's buffering. Okay. Children. So even if you see the people moving, center of mass is not moving. Similarly, ekkada kuda oka bomb ra. Okay, if you have a bomb ante telusa, grenade. Okay, you have a grenade and there are some metal pieces kept on it. Okay, so there are metal pieces on it. When the bomb explodes, andarki chudandi, explosion of a bomb, it's completely happening due to internal forces. Internal. Nobody has pushed the bomb, nobody has kicked the bomb. The bomb exploded by himself. Yes. So if you talk about center of mass frame of reference, before the explosion, the center of mass was here. Explosion tarvata kuda the center of mass also remains at the same place, right? It will not change. Okay, the center of mass remains the same. Explosion is the best example. Understanding? Okay. So if the object by itself is moving, if the total object by itself is moving, then and only then the center of mass is also moving. Ledante, if you are considering the elements of the object, in that scenario, the center of mass does not move. I will tell you the best example. Student. So let us say this is a river. You understand? Okay? This is a mass m1. Andariki chudandi. This is a mass m2. It's a very famous concept. Okay. M2 and there are people, right? They are people only. Okay. They are people only. Okay. Yes. So let us say their center of mass is somewhere here. Can any one of you tell me the value of center of mass? Cheppandi. If the distance is d, what is the distance of the center of mass from mass m1? Distance of center of mass from m1 kavali andariki cheppandi. So can I simply say, sir, this distance is going to be m2d divided by m1 plus m2. Ade kada? Right. And this distance will be cheppandi andariki. This distance will be m1d divided by m1 plus m2. Ade? Right. What's happening now is these two masses, they are going to come towards each other. Okay, these two masses, they are going to come towards each other. For example, gravitational force of attraction is there between them. Okay, there is gravitational force of attraction, leda electrostatic force of attraction, leda whatever force is there, but internal force is there. Internal force ante telusa. Nobody should give them external force from the outer side. If this is a positive charge, if this is a negative charge, all the forces, they are from themselves, internal forces kada. Yes, if this is a positive side charge, this is a negative charge, they are attracting by themselves. Point number one, remember, internal forces unte the center of mass will not move until the center of mass will remain at this position only. You understand this? It's a little complicated process to understand, but this mass is coming towards the other mass. It is also coming towards the other mass, and they are getting attracted. Masses are moving, but center of mass is not moving. Enduku sir? Endukante no external forces there. Mottam forces ante internal forces only. Okay, science chuddam. I'll see. I'll tell you everything. You don't worry about it. Okay, you don't worry about it. Choose. My question is, you understand? It's a very deep question. Okay, you understand. My question now is, if the mass m1 moves distance x-ray, okay, if mass m1 moves distance x until this m1 was here, now after moving distance x, the m1 came at this position. Ade kada? Yes. Center of mass not changing. Center of mass not changing. You remember the formula for center of mass. Three things we have to keep at the same time in your brain. Point number one, center of mass not moving. Point number two, these two masses are moving. Ante point number three, the value of center of mass remains the same. Right? Value intira center of mass ki. First of all, tell me the value of center of mass. R bar center of mass is equals to M1 R1 bar plus M2 R2 bar divided by M1 plus M2. Ade kada? Yes. So, sir, in rendu scenarios lo, the center of mass is not moving, but the masses are moving. And if the center of mass is not moving, the formula should remain the same. Ante kada? But sir, R is changing, sir. Initially, R was total distance, but now the mass has shifted. So that means R has decreased now. Ekkada kuda the mass is coming to the left. Ante R value is decreasing for this mass also. Understanding? So now my target is to keep the center of mass at the same position. Chuskondi andariki. M1 moving, for sure M1 is moving. To keep the center of mass at the same position, how should M2 move so that the center of mass is at rest? Understanding? So these are the two masses, sir, M1 and M2. Chuskondi andariki. So these are the two masses, M1 and M2. Ante kada? Right. I should take something like this. Black color is not visible to you. Right. So this is my first mass M1 and this is my second mass M2. Andariki. Cheppandi. Okay, center of mass is in somewhere in the middle. Okay, center of mass is somewhere in the middle. to keep the center of mass at rest. If this is moving, this should also move, ra. If this is moving, this should also move, ante kada. Then and only then the center of mass will be at rest. Now question is, if it is moving by distance x, okay, if this is moving by distance x, how much should it move so that the center of mass is at rest? This question ni solve cheyadaniki you have to choose the origin. The biggest hidden secret, nobody tells you. The entire answer is actually dependent on the origin choice. So if you are choosing distance will be positive, right side, and left distance will be negative. Are you understanding? Okay, so am I buffering for everybody? Okay. Okay. So first distance will be positive for right side, and the second distance will be, I'll tell, nobody. The most important secret for this is the choice of origin. So if you are choosing the best origin, that means your 50% question is dead. Understanding? So what is the origin choice? You must select the origin to be at the center of mass. In which questions, sir? In the questions where the particles are moving but the center of mass is not moving. You understand? You have two different options. In the first option, you have to calculate the center of mass. In a scenario, you can choose the origin to be one of the masses. But when the objects are moving and you have to calculate the distances keeping the center of mass same, in that case, your origin must be your center of mass only. Understanding? Yes. So let us compare the two scenarios. What are the two scenarios, sir? Initially, mass M1 was here and mass M2 was here. Let us say the distance between them is D. Andariki chudandi. Either distance D kada. Chappandi, where is the center of mass? Where is the center of mass? Sir, the center of mass is at this point. Value enti, sir? Sir, this distance of center of mass will be M2D divided by M1 plus M2. Ade kada? This is the first scenario. First scenario enti before any motion was started. This is the scenario where there was no motion started. Okay? Chappandi, this distance ki value enti, sir? This distance is gonna be M1D divided by M1 plus M2. Ante kada? Yes. So these are my initial instances. Final scenario lo, this mass has moved some distance x-ray. Andariki chappandi. Final scenario lo, origin remains the same. And the center of mass remains the same kada. I want the same center of mass. So first of all, I am writing the center of mass. Chudandi andariki. So this is my center of mass. Same position. The position of center of mass has not changed. But the position of the particles has changed kada. Yes. The position of particles has changed. So let us say this is my first particle now. How much distance it has traveled? Tell me smartly, okay? Tell me very smartly how much distance it has covered. X kada. So after covering distance x, it came to this position. Tell me this distance now, origin to this distance. Chappandi. Can I simply say, sir, M2D by M1 plus M2 minus x? Can I say that distance, right? So this distance now is M2D divided by M1 plus M2 into, minus x. So this is the distance. Ade kada, this is the new distance. Okay. What should be the new distance of the second particle? This mass is M1, this mass is M2. What should be this distance so that the value remains the same? Ante telusa? Okay. So instead of these complicated values, let us imagine the distances are R1 and R2. Very simple, okay? Answers is this only, but for simplification purpose, I am initially telling R1 was there, R2 was there. Ante kada. Now, if those values are R1 and particle has moved by X-ray, this distance will be R1 minus X. Ante kada. Yes, R1 minus X. I don't know this distance. I don't know. Okay, I don't know this distance. So let us call this distance as Y. Naku Y ki value kavali. Ade kada? Yes. Center of mass formula. Tell me the center of mass formula from this. Tell me the center of mass formula from this. Sir, R center of mass is equals to M1 R1 bar plus m2 r2 bar divided by m1 plus m2 ante kada. Yes. What is the value of center of mass position? Did I say you that I am assuming origin at center of mass? Did I say that? Yes. Yes. So that means center of mass is origin ante radius of the distance of center of mass from origin will become 0 because it is origin only. You can assume origin to be anywhere. Accordingly the distances will change kada. Ippudu r1 bar will become minus r1 ante kada. Yes. So it is equals to m1 into minus r1 చెప్పండి plus m2 into r2 అదే కదా divided by m1 plus m2. All of you, I hope you are understanding what I am telling. Here also origin is at the center of mass ante value remains the same ray. 0 is equals to m1. Now what is the value of r1, sir? R1 is negative of r1 minus x. So negative of r1 minus x plus m2 r2 kada. So m2 into y divided by m1 plus m2 ade kada. Finished. I hope you are understanding this, right? So you equate it with this side. So sir, m1 plus m2 is in division, send there in multiplication, gone ra. Aa tarvata you have m1 into, I am simplifying this, you understand if you are understanding, x minus r1 plus m2 into y is equals to 0. Leda you want to take the same thing, you can take the same thing also. Okay. Plus m2 into y is equals to 0. Or you can simply say, instead of this, negative of r1 minus x. Ade kada. So this negative term goes there, becomes positive ray. So you have m2 into y is equals to m1 into r1 minus x. Understanding? Yes. So sir, what you can say, I want to calculate the value of y, right? So y is equals to చెప్పండి అందరికి m1 divided by m2 into r1 minus x. Finished. So this should be the value of y. Y ante telusa, y ante entira, y ante distance. The total distance was r2 andariki. The total distance was r2. చెప్పండి. The total distance was r2. The total distance was r2. From that r2, it has covered some distance and became y ray. It has covered some distance and became y. I want to calculate that distance. It's confusing. Too much confusing. Is it confusing? Let us take the different approach. Let us finish this approach first. Okay? So initially distance was r2. It has covered some distance. This distance d ray, and then it became y. Kada? Then it became y. So sir, can I simply say from this relation r2 minus d is equals to y? Ante d is equals to r2 minus y. Understanding? D is equals to r2 minus y. You substitute the value of y into it, you will be getting the value of distance that must be moved. Leda, you understand. I will tell you. Okay. The other method to do this is your mass m1. This is your mass m2. It is the second method. Okay. This is the mass m2. Let us say here is the center of mass. Okay. Let us do the assumption that the center of mass is somewhere here. Andariki. Are you understanding? Understand. Let us say this distance is r1 ante kada, and let us say this distance is r2 andariki cheppandi, right? Origin is here only. All of you, this is my origin. Center of mass is origin kada. Tell me the formula for center of mass. R bar of center of mass is equals to m1 r1 bar plus m2 r2 bar divided by m1 plus m2. Understanding? Origin is at center of mass. Origin center of mass lo unte it becomes 0 kada. So 0 is equals to m1 into r1 bar entira left side. It is at the left side. So minus r1 plus m2 into r2 divided by m1 plus m2. Understanding? So from here you send this m1 plus m2, that is division, it goes multiplication, becomes 0 is equals to minus m1 r1 plus m2 r2. From here andariki chudandi. So minus m1 r1 goes here, becomes plus m1 r1. So m1 into r1 should be equals to m2 into r2. all the times this relation must be followed. All the times. You can simply say this is the relationship between your motion of the center of mass. So for example, you understand, okay, for example, you understand this. If your m1 mass is moving some distance x-ray, your m1 mass is moving with some distance x, kada? Yes. So what should you say, sir? Instead of this r1, you can directly substitute the values of x-ray. So sir, m1 into x must be equals to m2 into x dash. I want to find the value of how much it is coming, right? I'll call it x dash. Directly you can say that also. If you want, you can directly say that also. How am I doing? How am I doing? Chapu. Sir, if it is moving distance x-ray, the particle came and here. And similarly, it has moved x dash, the particle came here. Chapu, distances chappandi andariki. So this becomes r1 minus x and this becomes chappandi r2 minus x dash. Ade kada? Yes. At all the times, the distances must be following this formula. Ante m1 into distance must be equals to m2 into distance. m1 into what is the distance, sir? Distance now is r1 minus x. This should be equals to chappandi m2 into what should I write? R2 minus x. Ade kada? X dash, x dash. So sir, multiply m1 r1 minus m1 x must be equals to m2 r2 minus m2 into x. But coincidentally, m1 r1 is equals to m2 r2 initially. Ante m1 r1 is equals to m2 r2, they are gone. So you can simply say m1 x is equals to m2 into x dash. So ikkada nunchi you get the value of x dash is equals to m1 x divided by m2. You understand what I'm telling to you? No. Center of mass at rest. First mass covered the distance of x. Center of mass at 0, origin. First particle covered the distance x. This should cover x dash. The relation is that m1x must be equals to m2 into x dash. Ante kada, let us take a question. Okay. Chappandi, chudandi. So let us say this is my first mass 10 kgs andariki. Okay, 10 kgs. This is my second mass 20 kgs. Okay. This now they are working in the internal force. Internal force ante center of mass remains the same. It must not change. Ante kada, center of mass should not change. For the internal forces, center of mass should not change. Question chudandi. Question simply says that if the 10 kg particle, okay, I'm just giving you the distance between them. Okay, so let us say the distance between them d is equals to 100 meters. If this person or this 10 kg has moved the distance of x, or let us give you the value 10 meters, how much 20 kg will move so that the center of mass remains at rest? So that the center of mass remains at rest. Chappandi andariki. How much should the second mass move such that the center of mass remains at rest? I can see 90% of the students, they are not giving any attention. It's not my house, sir. Why should you listen to you? We are coming here only for time pass. Right? Time pass only, sir. Time pass only. Ade. Five. Let us see. Gonad, let us see. By the way, Gonad, I forgot your name. Can you just tell me your name again? I think it's Lalita, right? If I'm not wrong. Okay, simple formula. M1 x1 should be equals to M2 x2. Other M1 value 10 should be equals to 20 into x2. Good. So x2 is equals to 5 meters. Very simple. Short questions, short answers. Finished. Okay. Okay, good. Next. In this question, I'm going to ask you one more scenario, okay? I think we should directly go from your PYQs, okay? Okay. So now, let us go with the PYQs. A man of mass 100 kg, okay? A man of mass 100 kg is standing on one of the edges of a boat. Okay, is standing on one of the edges of a boat of mass. Let us say the mass of the boat now is, should I say boat or should I directly give you a boat of mass 300 kgs and length 160 meters. Full stop. If the boat is in still water, okay? If the boat is in still water, and the person moves to left by 10 meters. Find the distance covered by boat. Leda moved by boat. It's an elementary question, okay? It's a very elementary question. It's a very elementary question. In this, we will be adding two different masses, okay? So this is the boat. You observe it. So this is the boat. Boat ki mass ante capital M is equals to how much? 300 kgs kada? Yes, 300 kgs. And the length of the boat is 160 meters. Good. So this length is 160 meters. This boat is actually placed in still water. Ante this is the water. And some person is standing right here. Andarki chudandi. So this is a person. Mass of the person how much? Mass of the person is 100 kg. Okay? 100 kg. Sir, who is this, sir? Who is this? Naga teliyadara. You must know it. If the person is moving by 10 meters, the boat will move to the left, right? If it's moving to the left, the boat is moving to the right. Man moves to the left and a boat moves to the right. How much boat distance the boat moves? I want to calculate that only. Cheppandi andariki. No, Ritik, it's wrong answer. Good. Vikshita, I know your name, Vikshita. In each and every line, I'm telling the same thing. I know it. I know your name, don't worry. No, Ritik, it will not move by 2.5 meters. How are you saying it will move by 2? No, it will not move by 2.5. You imagine it. So it's a complicated scenario, Kada. I told you how to simplify it. How to simplify it? First thing you do is replace everything with a point mass. Point mass ante enti sir? Replace everything with points re. And you imagine this is the system. Idena mass kada person. So this is my person. Center of mass. 100 kg mass ra. Okay. This is your boat. Length of the boat is 160 meters. Length of the boat is 160 kada. Yes. 160 ante the center of mass of boat will be somewhere here. And this distance now becomes 80 meters. So now what I'm doing is I'm focusing the entire mass of this boat on the center of mass, right? Yes, I'm focusing the entire mass of the boat on the center of mass and I'm writing right here. Choose one. So this is my boat. Mass of the boat M is equals to 300 kgs. Distance cheppandi andariki, distance. Actually does not matter, okay? Whatever the distance is, does not matter. 80 meters of distance is there. If the person is moving by distance x, m1, x1, m2, it should move distance x2 kada. Formula remains the same. m1 x1 should be equals to m2 x2. m1 value is 100, x1 value is 10. Should be equals to m2 value is 300 into x2. Ade 0 zeros gone. x2 is equals to 10 by 3, approximately equals to 3.333 meters. Good. Gitanjali, very good. Very good. Okay, good. Now tell me your approaches. How are you doing that? How are you doing it? Hi. Kesava Narayana, your name is Honey. Right? Your name is Honey. Good. 3.3 meters. Good. Very good. Now, let us talk a little extension of this same question. Okay, Andariki. If you are not understanding some things, if you are really not understanding some things, okay, yes. Length is 160, but center of mass is not length does not matter, Ritik. What yedaina length it is. It does not matter in calculating the answer, okay? Good. So now let us move towards a little next stage. So for the students who don't know, okay, good evening Jani, Jan, good evening Janshi. I'm getting confused at the names for now. Chuskondi. The test will be on 4th of January, dan tarvata 11th of January, and then 18th of January. So these are the days. Every week, 4th of January in the sense Sunday, 11th of January next Sunday, 18th of January next Sunday. So continue 3 Sundays you have tests. For everybody who has not registered for this test, I am again Malibali Chetunnanu nenu. It's a very important decision. It's a very important step, all of you. Okay, good, very good. Go on, very good. So for those who have not registered for the test, go and register. If your scores are less, don't worry. Don't get demotivated. If your scores are good, don't get too arrogant. Okay, be in the mid-range. These tests decide the level where you are right now. Okay. And when you will be, after 3 months, it is decided only by your hard work. And that hard work gets a proper direction with these tests. Okay. So, Andariki, It's a really good initiative. It's a really significant step. All of you, whoever has not registered for the test, go, link in the description, registration absolutely free. Keep yourself registered and then let us see. Okay, for whatever marks you are getting, it also gives me also some idea. Okay, so I request all of you, ఒకసారి test ఇచ్చిన తర్వాత in our live, you tell me your marks so that we get a proper idea how to do. And yeah, NEET only, Nandini, NEET only. You did not see, what is it, Nandini? What is it? NEET kada? Yes. Okay. Suma, it's okay. Fine. Okay, yes. So these are all the stuffs. Okay, you can register. The link is in description. Now, let me go towards the syllabus. Will be full syllabus. Okay, everything is actually mentioned. So you will get. I don't know if you have registered it or not. Okay, sorry, you register it, you will get the material also. Right? So that's the biggest good news for you. You will get material. So in that you will get a lot of information how the things is going to be. Syllabus, some sample papers also. Okay, some sample questions also. Yeah, it's my style. Okay, it's my style. Okay. I can speak British English also. I can speak American English also. But what happens is this idiot, he is flexing. No, I don't want those comments. So let us take a little extra version of whatever we have discussed in the last class. Student, yeah, you can register anytime. Okay. Yeah, Nandini, thank you so much. Okay, that's a huge thing. So where did 98% of the charging has gone? Reels, Huh? Anyway, sure. Yeah, the biggest achievement for you in this chapter, each chapter nunchi, if you are, the class will be till 8:30. Okay, mostly by 8:30 or 9. I don't know how long it goes. Okay, you understand. The biggest achievement for you, if you have achieved it through today's class, Lega, if you had this knowledge from previously also, you congratulate and clap for yourself. Andariki, you clap for yourself. I am clapping, okay? I am clapping for you. If at all you understood how to replace a given mass with a point mass at its center of mass. If you understand that, your total chapter is completed, according to me. Okay, the only thing that remains is collisions. Finished. Okay, other than that, if you have understood how to replace the complex masses with their point as a center of mass and the total mass over there, very welcome. Congratulations, Andariki, if you have understood. If you have not understood, congratulations, your center of mass is never gonna improve. Okay, if you understood how to replace the systems with their point masses, no, not at all. Go not, Suma, not at all. Negative feedback, positive, it's nothing like that. You give it and that's it. Okay? You don't care on feedbacks. Yeah. Chuskondi. Now, what I would suggest is, if you understand how to replace the complex masses, with their center of mass as a given point, very congratulations, you have unlocked the biggest secret in the entire center of mass chapter. Okay, good. So with that secret only, we are moving to this question. Andariki chudandi, I'm telling you the biggest thing. Okay, two persons are there, right? Mr. Yeah, Nandini, absolutely. you, even if your preparation is not done till the last day of your examination, don't feel negative. That is the worst scenario. That's the worst. But I'm telling in a different way. Okay, take it in a different way. Okay, if you are thinking negative, gone, finished. Nothing could be done. Nothing could be done. Okay. Okay. So let us take two people. Who two people? Random people. Anyone there in the chat? Okay. So Mr. Sharma. Are scientist తీసుకుందాం. And the two ends of the boot. Full stop. Okay. Let us give some masses. Okay. Mass of Einstein. What is the mass of Einstein, sir? Yeah. This country. I don't have options, Ritik. I made it by myself. Okay. I made it by myself. But although there is this question in your PYQs. No. No, that's a wrong answer. 8 meter plus 4. 12 meters is a wrong answer, okay? If you are done with this chapter, well and good. Leda, we will have to continue it in the next class also, or tomorrow's class also. So I might have to. Okay, I'll explain the question. Choose. So still water ante normal water is there. Okay? River, for example, your river silently staying river, not moving anywhere. Still water is important. ఎందుకంటే if the water is not still, అంటే water will exert force on the boat. I don't want that. Okay? Okay? Good. Okay. So this is the boat. Okay? ఇదే నా boat రా. Understanding? The length of the boat is 100 meters kada? Yes. So the length of the boat is 100 meters and the mass of the boat M is equals to 150 kgs. ఈ boat పై two scientists of the history, two biggest scientists of the history, Mr. Einstein and Mr. Newton, they are standing. అంతే కదా? Yes. If any one of them moves, it's a very complicated situation, right? If any one of them is moving, boat will also move. అంతే కదా? If you are moving forward, ante the boat will move backward kada? Yes, the boat will move backward. If I am moving forward, the boat is moving backward. Ante kada? Yes. Okay? Right. So the question says Albert Einstein has moved by a distance of 8 meters. Newton moves 4 meters. And Albert Einstein has covered 8 meter distance and he came here. Newton covered 4 meter distance and he came here. Boat will not sit ideal, right? Boat will also move left or right. Naku teliyadu ra. How much? Adi kuda teliyadu. You have to calculate both the things. చెప్పండి అందరికి. Hi Vaishu, hi. Hi Vaishu, hi. I've seen your message. Okay, I have seen it. You did not understand the question. So I've told you the biggest achievement you can achieve is if you have learned the technique. Aim technique, sir, to convert the given masses into point masses. Understanding. If you have learned to convert the given masses into point masses, ante center of mass తీసుకోండి. ఈ center of mass పై if you are considering all the mass, focus on the center of mass only. Satvika, the duration of the class నాకు తెలియదు. I actually don't know, okay? And I'm feeling that the chapter will not be completed even after 5 hours of class. We are going with some minute details. This chapter has your Newton's second law completely embedded into it. Dan tarvata vectors also it's there. If this is a strong chapter ante it is the middle part of the mechanics, center part of the mechanics. We have completed these chapters forward, same chapters are remaining. So if it's good ante done. So what I was telling to you is, if at all you have understood how to convert the given masses into point masses, your entire question has been dead. Ela convert cheyali sir? The first thing that you take is the center of masses of each of the shape ra. Center of mass of Einstein is somewhere here. Okay, center of mass of Newton is somewhere here. Center of mass of boat is somewhere here, but you can shift it here, right? No problem. Ante 3 masses. 1, 2, 3. Entire diagram has been simplified into 3 masses only. So first I want to calculate this. You understand, these questions are not required for you, but it has been asked in your PYQs. It has been asked, okay? It has been asked in your PYQs. Ade. Kabatti I am telling you all these things. Not buffering, right? It's not buffering now. Is it buffering? Is it still buffering? Andariki? Is it clear now or still buffering? Good. Great. So first of all, calculate cheskondi center of mass. Sir, assume origin at any point. M point, you assume here, origin. Now directly tell me, length of the boat 100 meters kada. So this comes out to be 50 and this comes out to be 50. And then now you tell me the formula. Sir, R center of mass is equals to M1 R1 bar plus M2 R2 bar plus M3 R3 bar whole divided by M1 plus M2 plus M3. Ide kada. Can we take till 9:30? Can we take the lecture till 9:30 andariki? Okay, can we take the lecture till 9:30? If 9:30 is good, then we can easily cover this chapter. I believe. I don't know. Okay, I don't know anything. Chuskondi. Directly substitute the values. R1 bar is 0 kada, so it's completely going to be 0. R center of mass is equals to, cheppandi, M2 value antara, M2 is equals to 150 into R2 how much sir? R2 is 50 plus M3 value is 120 into R3 value is direct 100. Total distance 100 into 100 divided by sum of all the masses 120 plus 30 plus 150. The masses are given in such a way that the total mass comes out to be 300. Finished. Ide kada? Yes. Now when you calculate it, you will be getting coordinate of center of mass is equals to 150 into 50 plus 120 into 100. Ade kada? So sir, 150 into 50 plus 120 into 100 divided by the total mass, that is 300 kgs. How will you simplify? 150 into 50 becomes 7500 plus 12000, right, divided by 300. And 19500 divided by 300. So 00 gone. Okay? You can simply say 3 ones are 3, 3 6 are 18, 65 meters from the, it is 50. 65 meters from the origin ante, this would be the center of mass. This distance will be 15 meters. Ante kada? Yes. This distance will be 15 meters. Now, what you will do is, you will simply write the formula. What formula, sir? Sir, M1 R1 bar. Now, this value, whatever value has come, you will assume this as origin. You are shifting the origin twice. Understanding, you are assuming the origin twice. First time, you are assuming the origin here. Okasari mi center of mass ochindi ante, you are shifting the origin over here. Ante kada? Right. Now, think from center of mass perspective. Sir, M1 R1 bar plus M2 R2 bar plus M3 R3 bar must be equals to, divided by M1 plus M2 plus M3. Center of mass kada? Divided by M1 plus M2 plus M3. This is my center of mass and it must be 0. And this expression should be 0. Dan tarvata, you understand, okay? You are telling, sir, M1 R1 bar plus M2 R2 bar plus M3 R3 bar must be equals to 0. Understanding? Why 0, sir? Division, you send there, it goes in multiplication and this answer comes. Let us do some changes to R1, R2, R3 just for fun, right? Just for fun. Okay, just for fun. What changes are you gonna do? Sir, M1 into R1 bar minus X1. Ade kada? So if the particle is moving towards right, this is the origin. Chuskondi. First distance is R1. Second distance is R2. Third distance is R3. Ide kada? So if it's moving X, it becomes R1 minus X. Here also, moving towards the left, R2 minus X, R3 minus X, vector form. Let us go towards the conclusion only. X1 bar plus cheppandi andariki M2 into R2 bar minus X2 bar plus cheppandi andariki M3 into R3 bar minus X3 bar should be equals to 0. Enduku 0, sir? Even if the distances are changing, center of mass is not changing. Initially also it was at origin. Here also it is only at the origin only. Ade kada? Yes. So now you simply simplify it. Ante M1 R1 bar Okay, now understand. Minus m1 x1 bar plus all of you, m2 r2 bar minus m2 x2 bar plus m3 r3 bar minus m3 x3 bar should be equals to 0. Ante, can I simplify it? Ante, I will simply say, sir, m1 r1 bar plus m2 r2 bar plus m3 r3 bar must be equals to, or leda, not going directly, minus common this one, minus m1 x1 bar plus but you observe equation m1 r1 m2 r2 already 0 ante this already becomes 0, so that means this should also become 0. x1 x2 x3 are the distances moved by the objects. Okay, distances moved by the objects with respect to center of mass. Andariki distances moved by the objects with respect to center of mass. Now where the center of mass is, that decides the value of x1 x2 x3 ante kada, right? Cheppandi. So what I'll say now, I'll simply say, if you have three masses, now remember, all this was conclusion, proof, derivation kada. Now I'm writing this main formula. You understand main formula other. Mass is m1, ekkada uchi mass is m2, and here mass is m3. Andariki. Okay, right. Let us say it is moving some distance x1. Center of mass, that depends. Okay, that depends. Let us say this is moving x2 and let us say this is moving x3. Okay, what is the formula? m1 x1 bar plus m2 x2 bar plus m3 x3 bar should be equals to 0 now. So basically their mass times their displacement sum should be always equals to 0 ra. You come here to the original problem and tell me, andariki center of mass is here kada 65 centimeter. ఇప్పుడు చెప్పండి directions of motions ra. Einstein moving towards the right side. Right side we are assuming to be positive. Right side we are assuming to be positive. Automatically Newton moving towards the left side, it becomes negative kada. Yes. Cheppandi x1 for Einstein how much ra? Enta x1 for Einstein value 8 meters re, 8 meters. x2 for Newton value, sorry x3 for Newton value enta sir minus 4 meters. Naku x2 kavali ide kada, x2 ki value enti? Directly substitute cheppu. So you can simply say, sir, mass of Einstein is 30 into 8 m1 x1 plus mass of boat is 150 into x2 bar. I'm taking bar plus mass of Newton is 120 into displacement left lo untundi kada, so minus 4 should be equals to 0 ra ide. So you can simply say 240 plus 150 into x2 bar minus 480 should be equals to 0. 240 minus 480 is minus 240 andariki, so it becomes 150 into x2 bar gone. x2 bar okay, x2 bar minus 240 is equals to 0 ide kada. Yes, so sir minus 240 becomes plus 240 cheppandi andariki, so it becomes 150 into x2 bar is equals to 240. Ekkada nunchi you can simply say x2 bar is equals to 240 by 150. 0 gone, 8 by 5 meters. Positive negative ra? Positive unte the boat is moving towards the right side. 8.5 ante telusa, it is approximately equals to 1.6 meters. So this is the distance moved by boat in the right side. Okay, if you understood this question, that means you have unlocked the next level of understanding. Ardhamaindi? If you are understanding this question ante you have unlocked the next level of understanding. Leda let it be. Okay, let it be. Things will keep on going. Okay, nice. Next చూద్దాం అందరికి. Motion of center of mass. Are you tired? అందరికి? చూసుకోండి. Good, good. Okay. We'll end this session by 8:15 and let us take part 2, okay? Even my health is not feeling good. So tomorrow will be part 2 for center of mass only. And then we'll discuss part 2. Sunday we might be taking about yeah, it's okay. I'm understanding your situation. Okay, I'm understanding. That's why. Okay. Speed and acceleration. Let us see this and let us stop. Chuskondi. Sir, R bar center of mass. Sir, R of center of mass. Sir, R bar of center of mass is equals to M1 R1 bar plus M2 R2 bar plus so on Mn Rn bar kada divided by sum of all the masses ante M1 plus M2 plus so on up to Mn. This is my position vector of center of mass. Differentiate it. What you get is, you will get something like this. Choose one. When you differentiate it, you get velocity of center of mass is equals to M1 V1 bar plus M2 V2 bar plus so on up to Mn Vn bar whole divided by M1 plus speed of center of mass, velocity of center of mass. Next, you talk about acceleration of center of mass. A bar Cm is equals to M1 A1 bar ante independent particles ki acceleration తీసుకోండి into the formula and then you divide it by the total mass. Ide understanding. Plus చెప్పండి అందరికి M2 A2 bar plus M3 A3 bar and so on up to Mn An bar whole divided by M1 plus M2 plus Mn. Ide. So this is your acceleration, this is your speed. Okay? Acceleration ante telusa Newton's second law. Cheppandi, what does Newton's second law says? Sum of all the forces acting on a body, vector sum, okay, up to Fn is equals to mass of the object. Mass ante em mass ra, total mass M1 plus M2 plus M3. It is total mass kada? Yes. Multiplied by acceleration of center of mass. Cheppandi, what is acceleration of center of mass? M1 A1 bar plus M2 A2 bar plus so on divided by M1 plus M2 plus M3 plus so on. Either. It's denominator, it's numerator, gone. So you can simply say F1 bar plus F2 bar plus F3 bar plus F4 bar up to so on Fn bar is equals to M1 A1 bar plus M2 A2 bar plus so on up to Mn An bar. Either. So this is the Newton's second law in the most appropriate and best way. This is your Newton's second law. Okay. For now, remember these formulas, all of you. And from tomorrow, in tomorrow's class, I'll be starting from the same point. Okay. Speed and acceleration of center of mass. And from here, we will start, and perhaps mostly by the end of tomorrow's class, that is by 8:15 or something, we'll be done with this chapter. Okay. I at least need 7 to 8 hours minimum. Okay. Right. So I was telling, just give me a minute. Someone is telling me something. I'm receiving a call actually. Yeah. So if you don't have any doubts, then I don't think there is a problem in winding up this session, right? So how long it has been going? 4 hours, 14 minutes. Only 4 hours, 14 minutes. Right. Bye, all of you. Bye. ఏదైనా డౌట్స్ ఉంటే చెప్పండి అందరికి. వాట్ ఎవర్ డౌట్స్ యు ఆర్ హ్యావింగ్, యూ క్యాన్ ఫీల్ ఫ్రీ టు ఆస్క్.